Good morning and welcome to day 2. We'll just wait for folks to dial in. We'll just give it another minute before we kick off. Right, I think we'll start now. So welcome to day 2 of this workshop. For those of you who attended yesterday, I hope you found the discussion productive, informative and collaborative. I know that I did. We covered a range of topics, including situational awareness, risk assessment and modelling, and vegetation management. And if you didn't manage to dial in, then you can catch up with the conversation via our YouTube channel. So both days of the workshop are recorded and they'll be uploaded to our energy safety YouTube channel in the coming week. So just in terms of today, I wanted to remind both the panelists and the public comment and discussions to focus on the questions for discussion, so on the recommendations for the safety requirements. I'll be facilitating today, and Emily Ginsberg from my team will also be facilitating one of the sessions. So if we just move on to the safety briefing, and then I can discuss how to participate and then go through the agenda before we kick off with the first session. So for the safety briefing, it's the same as yesterday. Take care of your posture and sit in a comfortable position. So this is an all-day workshop. We are finishing a bit earlier than we did yesterday, but remember to take regular breaks, stretch, hydrate. It's getting pretty hot right now. Rest your eyes. In terms of being prepared for an emergency, know your emergency exits and procedures, should you need to use them. Keep emergency contact information readily available. And as Colin mentioned yesterday, we're in an earthquake zone, so please be prepared for earthquakes. Moving on to how to participate. So this is exactly the same as yesterday. If you want to provide input to the discussion, please press the raise hand button on Zoom. You will then have the ability to unmute yourself and I'll call on you in order of hands raised. If you're dialing in, you need to press #2 to raise your hand. Also, the Zoom Q&A feature is provided, so you can write out questions if you prefer to do that. And the objectives for today are exactly the same as yesterday. What we want to achieve is we want to facilitate stakeholder feedback. So we want to understand the diverse perspectives and insights around the table. We want to promote public engagement, so have a collaborative discussion to explore these safety regulations and what recommendations there might be to reduce utility wildfire ignitions and the effects of climate change and ageing infrastructure. And we want to enhance communication and transparency, so provide clear feedback and participate in an open dialogue. So with that, I will go through the agenda for today. These first 10 minutes are the welcome and opening remarks. Then we'll move on to new construction, system hardening and grid operations. So we'll have 3 presentations from Green Grid, and then there'll be the panel discussion afterwards, followed by the public comment session. Then we'll move on to undergrounding. And we'll have a slightly early lunch between 11:40 and 12:40. Then we'll move on to asset replacement and repair frequency, and then inspection of assets. And then we'll move on to additional safety considerations and regulatory change impact analysis before we open up for an open Q&A session and finish with closing remarks around 3:30 this afternoon. So with that, we'll get started with our first presentation from Green Grid. So I'll hand it over to Nagar Mohorami, who's going to talk to you about new construction.
Thank you so much, Lucy. Good morning, everyone. My name is Negar Moharami, Senior Project Engineering with GGI Inc. Next slide, please. My topic for this workshop is about new construction. California legislators are making strides in fulfilling their commitment to electricity generated from zero carbon source by 2045. In this regard, SB 100 would accelerate the state's current renewable portfolio standard RPS program to 50% by 2025 and 60% by 2030. It further requires a state agency, regulator energy, clean air, and climate to implement the policy in all proceedings authorized under law. The budget for this project is estimated to be $2 billion. In this regard, new electrical grid construction considering local condition, heavy wind load, rising temperatures, soil conditions, access water. Next slide, please. Safety factors should be determined based on the few variables for specificity in regulations. You should consider the location and specifically should vary based on the HFTD, high fire threat district, and other potential high risk area. It should be different based on the local condition. This includes considering the impact of variable parameters such as wind, speed, ice, seismic, and climate change. Climate change poses significant challenges to the safety and resilience of infrastructure. As the frequency and intensity of extreme weather events increase, safety factors play a critical role in adapting construction practices to mitigate the risk associated with climate change. Safety factors relate to climate change and its impact on structural system safety. Increased intensity of extreme weather events, rising sea levels and coastal erosions, increased precipitation and flooding, temperature extreme and heat stress, wildfire and fire safety, adoption, and resilience. To prevent any structural failure, it's essential to consider safe design and construction practices that account for extreme weather conditions. This ensures the resilience of structural component against sudden incidents. Sustainable construction aims to minimize the negative environmental impact of infrastructures while creating structures that are energy efficient, resource efficient, and socially responsible. Integrating safety factors into sustainable construction practice is crucial to ensure that environmentally friendly structures also prioritize safety. By considering safety factors within sustainable construction, professionals can strike a balance between sustainability goals and necessary precaution to mitigate risks. Next slide, please. New construction project required meticulous planning and execution to ensure safety and mitigate potential risk. One crucial aspect of constructing any infrastructure is incorporating appropriate safety factors. These safety factors are essential to account for uncertainty, external forces, and unforeseen events that may occur during the lifespan of a structure. By considering safety factors, construction professionals aim to enhance the overall resilience and durability of the project. Safety factors, also known as factor of the safety or design factors, are numerical value applied to various structural components and material. They are typically higher than, yes, thank you so much. Numerical value applied to various structural component and material. They are typically higher than anticipated maximum loads or forces that the structure is expected to encounter. The purpose of safety factor is to provide a margin of safety, allowing for uncertainty and variation in construction material, design assumption, and usage conditions. There are several key areas where safety factors play a vital role in new construction, in structural design, extreme loads or stress without failing due to climate change, used for designing, constructing, and hardening electric infrastructure, wind, ice, or other environmental factors. Next slide, please. Location-driven safety factor. Considering all, it can be seen that safety factor can be different based on location. For higher fire threat district, HFTD, specific safety factor requires for Tier 3 and Tier 2. Specific safety factor requires for climate change impact, local condition. Others can be based on area impacted by red flag warning, high wind warning, based on soil condition, slope stability. Next slide, please. Safety factor provide a safety margin that remains after all anticipated loads and stress, reduce the risk of catastrophic failures. Electrical infrastructure need to withstand varied conditions and load due to climate change. Consider the overall integrity of the power line system. I have finished my presentation here, and I would like to invite my colleague Eric to present system audit.
Thank you, Dr. Moarami. Good morning, everyone. My name is Eric Pesima, Senior Project Engineer at Green Grid. During this time of the workshop, we will be discussing system auditing. I am joined by Dr. Moarami again, and also Kenneth Lam, who will be reviewing the topic with me. Next slide, please. Little background about system auditing. Okay, I'm hearing myself.
Can you please go, Ken and Nigar, can you both go on mute while Eric's talking, please?
Okay, a little background about system auditing. This process strengthens electrical infrastructure to make it more resilient, especially in the face of climate change, with the ultimate goal of reducing or preventing wildfire. Some common system auditing techniques include installing cover conductor, auditing overhead assets, modernizing equipment, locational safety factor, and undergrounding. Further explanation of this method will be provided as we continue with the workshop. Next slide, please. As we are all aware, of course, climate change is a global issue. In California, we have noticed irregular weather patterns that have directly impact the electrical infrastructure. These weather conditions include high wind events that cause wired objects and vegetation to wire contact, storm and lightning that lead to equipment failure and asset ignition, high temperature that cause asset overheating, and drought that dehydrates surrounding vegetation. In areas such as high fire threat districts, system auditing is prioritized to achieve increased asset resilience, improve reliability, and enhance operation and maintenance protocol. Next slide, please. Based on our observations, we have noticed that the general order includes rules for design, construction, and maintenance, protective covering criteria, splices, and taps. However, with the challenges posed by climate change and wildfire, it is necessary to establish new regulatory requirements. In current regulation, GO95, design, construction, and maintenance emphasize the importance of good faith practice. Protective covering criteria include considerations such as electrical insulating efficiency, impact strength, material-specific criteria, thickness, and sunlight resistance. The current provisions are not exhaustive. Splices and taps also have current provision, including the requirement for grade A construction to obtain consent from all parties and to avoid splices and taps in grade A construction span. Additionally, there is a maximum number of splices allowed per span. Next slide, please. Furthermore, with observation, to improve safety of aging electrical infrastructure, it is crucial to replace non-exempt equipment with exempt equipment. Exempt equipment allow for consistent monitoring and control of circuit status. Currently, only state regulatory agencies have access to this method, but there is an opportunity to establish regulatory requirements. Composite and steel pole have several advantages, such as design flexibility, high strength, lightweight, and low maintenance. Moreover, steel poles are not susceptible to damage caused by wood pokers, pole rats, or fire. Next slide, please. Welcome to our discussion points. We value the input of all stakeholders. At this time, I would like to invite my colleague, Kenneth Lam, to review some of these discussion points with us. Thank you.
Thank you, Eric, for the introduction. Hello, my name is Kenneth Lamb. I am a senior engineer with Green Grid Incorporated. I will be discussing 3 of 5 points regarding system hardening. Discussion point 1 is covered conductors. Covered conductors can reduce the risk of phase-to-phase wildfire risk and improve reliability. The areas of ongoing research are materials, inspection, and maintenance. The replacement of conductor lines can be installed as needed. Exposed conductors can decay while in service. Deformed and broken conductors can induce more heat to conductor lines, which the possibility of electrical failure can occur. Long-term effectiveness can be documented based on new service life. The potential failure modes can be further observed based on the latest procedures, electrical codes, and specifications. Let's move to discussion point number 2, reduce splice-caused ignitions. System hardening can be applied to splice systems. The potential causes of acid ignition are environmental conditions such as corrosion, moisture, and physical damage. Line splices can be installed to connect conductors. Splice protection protocols should be introduced to incorporate corrosion inhibitors. Frequent maintenance, inspections, and confirming the number of splices between spans. In other words, inspect conductors, splices, and apply corrosion protection over splices. Let's move to discussion point 3, hardening aging assets. Hardening of aged assets can also be considered. The aging assets may include non-exempt equipment, which has a potential to spark, tendency to overheat, and a higher likelihood of failure. Exempt equipment can be modernized with single-phase reclosures, motorized switch operators, rapid earth fault current limiters, and exempt surge arresters. My colleague, Dr. Nagar Moharami, will continue the system hardening presentation.
Nagar, you are mute. Unmute yourself, please.
I'm sorry. Thank you so much, Kenneth. For discussion point 4, over time, utility poles can deteriorate due to environmental factors such as exposure to sun, rain, wind, and extreme weather conditions. Wooden poles are susceptible to rotting, insect infestation, and general wear and tear. Additionally, accidents, vehicle collisions, or natural disasters like storms and earthquakes can damage utility poles, necessitating their replacement. Pole replacements refer to process of removing and replacing utility poles used for various purposes, such as supporting overhead power line, telecommunication cable, and etc. In recent years, there has been a shift towards using more durable material for utility poles, such as steel, concrete, and composite material. These materials offer advantages in terms of longevity, resistant to environmental factors, and reduced maintenance need compared to traditional wooden poles. As a result, pole replacement project may involve upgrading to more modern and reliable pole material. Fire retardant treatment are often utilized in context of the pole replacement to enhance the fire resistance of utility poles. Given that utility poles are exposed to various environmental conditions, including the risk of wildfire, Applying fire retardant treatment can help mitigate the potential for pole ignitions and the spread of the fires. Next slide, please. Residual safety factor, RSF, accounts for residual stress on the structural element. This one is as a discussion point number 5. This can be an alternative definition for reducing safety factor in regulations, considering the impact of environmental loads, winds, ice, and seismic. In demand capacity ratio, DCR calculation for structural components applies to new construction or existing construction after installation. I've completed my presentation. I would like to invite my colleague Kenek to present grid operations and protocols.
Thank you, Dr. Nagar. Okay, I will be discovering, hello, my name is Kenneth Lam once again. I will be covering grid operations and protocol backgrounds. Next slide. Effective and safe operation of the power grid can introduce system automations and protocols. This is to minimize the extent and duration of de-energization and facilitate flow of energy. A reliable functioning power grid can reduce ignition and wildfire risk. The grid resilience can be achieved with hardware and procedural updates. Next slide. Industry practices will be refined as energy utilities progress. Sectionalizing the infrastructure can complement existing automation and or update hardware. The sensitivity change of a protective device, such as a fast trip circuit breaker, can be installed to update electrical panels and buses. The line loading and powerful optimization can be configured to multiple grids. The PSPS threshold can have additional parameters and protocols as the network expands. The sectionalized customers could have a smaller footprint on the network delivery. Therefore, PSPS, power safety, power shutoff to a microgrid should have a smaller impact. Smaller group of should impact a smaller group of customers. Let's move to discussion point number 1. Mitigating impact of PSPS events. PSPS events pose operational risk challenges. Grid reliability and risk of public safety could be compromised. Developing a response protocol should or could be essential in cases where safety and health are threatened by catastrophic events such as fire and power outages. Power outages can impact life support systems located in hospitals and medical communities. In addition, the economy at different industries can be interrupted as well. For example, manufacturing and transportation. Impact reduction protocol could include sectionalizing the power system over advanced controls such as SCADA, supervisory control, and data acquisition. In addition, backups such as battery storage, microgrids, local renewable generation can be integrated for substation management and communication. Furthermore, backup generation for life support, emergency management, and commerce can be constructed for extended operations. Let's move to discussion point number 2, protective equipment and device settings. Power outages can be attributed to object contact, such as vegetation growth, animals of all sizes, and flying objects or projectiles. minimize wildfire risk through implementing protocols to reduce time to de-energize, rapid response for quicker power restoration, and to automate power shutoff. This concludes my presentation regarding grids and protocols background. I will defer to Luce Morgan from Energy Safety.
Thank you very much. Thank you very much, Green Grid, for your presentation. You've given us a lot of material to talk about, both on new construction, system hardening, and grid operations. So now I'm going to turn over to the panel discussion. We've got 4 panelists, and I'll kick off with the first panelist, who has approximately 7 minutes. So Matt Pender from PG&E, would you like to provide your feedback specifically on the questions for discussion that were posed by Green Grid in that last session?
Yeah, thank you for having us, and thank you for hosting this session. Really interesting discussion and areas to focus on. I also appreciate the fact that these topics were bundled together because they all relate to our sort of layers of safety as it relates to reducing wildfire risk on our assets for our customers. A few thoughts. One is the relationship between grid operations and system hardening. Grid operations is the area where we are in the moment making the system safer by how the grid is operated, and then system hardening is the way that we change that system to make it more resilient in the long run. And so there's an important relationship between those two, and so it's good that we presented them together, and it's important that we all think about them as we go forward. As the assets change because of system hardening, replacement of certain things like non-exempt equipment, it can change how we need to operate that grid. The reference to REFCL, for example, Rapid Earth Fault Current Limiter, was in the system hardening section, but that's really a grid operations tool also. So that's one point that we at PG&E think is really important, is to make sure that we, in all things, our regulation, how we operate the grid, how outside folks think about it, continue to focus on and be aware of the integration of those topics, right? The grid operations and PSPS, EPSS in our case, enhanced power line safety shutoff. Enhanced power line safety settings are all very interconnected. And in our case, or we view it very much that the next topic, undergrounding, is also very interconnected to this, right? Where we underground the lines, that's one kind of system hardening or maybe even new construction. And it changes the way we need to operate the grid when we have sections or whole circuit segments that are undergrounded. So that's point number one, is the integration of these things, which we talked about a lot of them sort of specifically, and we need to make sure that we're always thinking about them holistically. The other is the diversity of the system that we serve and the customers and communities that we serve. So the diversity of the geographies, the topographies, and the customer bases are significant. And so when we think about some of these tools and things like pole replacement, Green Grid emphasized different kinds of poles, composite steel or fire retardant wraps around wood poles. We think it's important to continue to have flexibility to use the right tool in the right place, right? Not every geography is the right place for a steel pole, for example. And so as we continue to evolve and grow and learn about how to use the right tool in the right place, we want to make sure that we can explain that to everyone as the utility, but also that folks are aware of the need for diversity in our selection choices for what to use to harden the system and make it safer. And that relates to the grid operations system also, which is that we're going to have diverse tools and stuff there. One of the discussion points was around having backup power in partnership with like sectionalizing devices, so that areas that are regularly impacted by PSPS or other outages, wildfire-related outages in particular, have the right backup and solution to keep them safe. The presenter mentioned hospitals and critical energy infrastructure partners. And so we think that's really important too. There was a little note on there about microgrids and that kind of thing. And we continue to believe that that's an important part of the solution here. It's not feasible everywhere. And so again, to the diversity point earlier, we need to have the right tools in our toolbox so that we can deploy them in the locations that make sense based on the diversity of our system. Lastly, there was talk at the very beginning about covered conductors and then reducing splices and hardening aging assets. That is all really important. And again, PG&E views it as in partnership with undergrounding. So we look at a circuit segment of high risk in wildfire area and identify what's the right solution. Should we overhead harden it or underground it? And we want to get to as much of that as we can as quickly as possible. It's of course not feasible to do that everywhere all at once. And so each of these topics is important. Getting covered conductor up in the air in place of bare conductor, replacing splices, replacing hardened or hardening aged assets. But as was talked about previously, the risk modeling and the risk quantification to prioritize where we go first is really important and critical. And where we cannot get to change the assets immediately is where we rely on the grid operations and the more sensitive safety settings and things of that nature. So I guess I'll finish there, which is, again, the integration of these multiple layers of wildfire safety risk reduction in terms of having the right grid operations, replacing assets aggressively with the right tools or assets for the geography, and having diverse options to overhead harden, put it underground, remote grid, microgrids are all really important as we tackle this wildfire challenge. That's it for me.
Great, thanks very much, Matt. The next panelist up is Ray Fougere from Edison, Southern California Edison. Ray, are you online, ready to talk?
Yes, I am. So
brilliant. So please add anything to what PG&E just stated, anything, in terms of anything over and above.
Certainly. One thing, because when we talk about regulations, there's one thing I really think of, and I want to give just a little background for everybody to understand a little more about me. So right now I'm the Director of Wildfire Safety for Southern California Edison, and I've been at Edison for a little more than 9 years. 14 years prior to joining Edison, for 14 years, I worked at the California Public Utilities Commission. And from 2005 to 2014, I was the Safety and Enforcement Division expert on General Order 95 and understanding regulations. So I have a very unique perspective when it comes to regulations. I understand how it works for the regulated body of the CPUC and also how it impacts utilities. So some of the things I just really want to point out when we're considering regulations is this is the one thing I really think I want to drive home, and it's building a little off of what Matt said, is we need flexibility. We need to make sure that the regulations aren't too constrictive, that make it challenging and don't allow for the utilities to have flexibility, because that's really important, because the California is a very diverse state. When we look at PG&E's service territory to SCE service territory and San Diego service territory, it's very diverse, and we need to have flexibility for the known local conditions and the unique factors that we face in our service territories. And even when we look at Southern California Edison, it's 50,000 square miles, and it's a very diverse nature in and of itself across. So as we're looking at these regulations, I want to make sure we allow that flexibility, because as climate change worsens, things are going to change. We need to have that flexibility to account for it. Sometimes when you codify something, there is a lag to change it. So make sure that there's ability for utilities to have that flexibility and change in some more real time, have it be a little more agile. So that's the one thing I want to just point out that we need to have as we're looking at it. Now, there's one thing in there about age of assets, and I get where people focus on age of assets. Age is a factor. I want to make sure we're not limiting that as the only factor, because it's one of the many factors that goes to asset health. So we need to look at more than just one factor. And I think that is really where we have risk modeling that looks at that. And we need to make sure it's accounted for there. So I'm not sure if personally requirement on age of assets is the best regulation. It's just one of many factors that we need to consider. And then some other things, when we look at safety factors, because there was a discussion on there, safety factors are important, right? That is how you maintain your asset health, make sure they're strong enough to withstand the conditions. And when we think about this, one other way, instead of increasing safety factors for high fire areas, is you can account for wind pressures. And Southern California Edison already does this. So right now, if you look at General Order 95, it has 2 wind loading conditions, light and heavy loading. What Southern California Edison did was we had a third party do a wind study, and they told us these are areas more likely to have higher wind. And we went through our whole service territory and utilize those, and we loaded every pole to those higher wind conditions to make sure that they could sustain those. So when we're thinking about that, I don't want to just focus just on safety factors. There's other ways to get there. So there's multitude of ways to get to the same result of making things stronger. So just wanted to point that out as a potential. And we are refreshing this. And this is where I go back to flexibility and agility. We're refreshing our wind study. So in case conditions have changed, as we've gotten more weather station, more information, we want to be able to update this in, closer time and stuff. So if you codify it, we may be delayed and you don't get the benefits of that right away. So just wanted to point out some of those things. And I fully agree with everything that Matt says. Really it is good that these are connected. Undergrounding is really also connected to this because they're all together how you reduce that risk of wildfires. The grid operations, the grid hardening, undergrounding, which I believe is grid hardening as well. In the totality, they all are connected. And so how you interplay with these, and so that's about it. Just some high level starting talking points.
Thanks very much, Ray. That's useful insight. I appreciate your presentation. So next we'll hand over to John Mader from the Wildfire Safety Advisory Board. John, over to you.
Thank you. Good morning, everyone. I want to reiterate both what Matt and Ray said about flexibility in solving problems and how this is all these solutions are interconnected. I did the planning for the capacity, reliability, and protection for Amador and Calaveras County for 15 years. And even that area itself is incredibly diverse, and there's different solutions to different problems. I've been looking at the wildfire mitigation plans from the 6 investor-owned utilities for 3 years now, and I can see that they're getting more and more sophisticated and more effective. But really, I'm going to try and limit my discussion to change of regulations today. And what I wanted to first start out with is areas I don't see GO 95 or 128 addressing. It's a building code, but it's also kind of a maintenance code on inspections. And I believe that both those rules should be both looked at from the perspective of fire, from avoiding fire starts, but also PSPS initiation, the shutting down of power. And one of the ways we can start doing that is having the rule address the ratings of the equipment that the operators should be required to make sure that their equipment is able to handle the load. It's able to, when it's called upon to interrupt the load, it's being able to handle the fault current and to be able to handle the interruption of that fault current when that's required. Equipment failure is one of the largest causes of sparks. And when equipment is either annealed because it's exceeded the fault current exceeds its ratings, or if it's called upon to interrupt current that it's not rated for, that's a potential area of a fault. So these are like 101 basics of operating the grid. But there's nowhere else. There's RC 4292, and then there's the CPC rules. There's really nowhere else to put a requirement for that. Something else, I think, and this is kind of touches on what Ray was talking about, having flexibility. I understand when you're trying to solve the energy needs for a community, you need to have all kinds of options, but some way to address that, as we have more intelligence on how our topography operates. What I don't hear is that we're talking about some sort of guidance on if you have choices to go in this route to serve a community or go that route, to go with the route that is least has the least fire risk or the least chance of spread. If the shortest distance is through a forest, or if it's along a highway that's cleared, maybe you should take the longer route. Now, I'm going to talk a little bit here about it kind of goes into the undergrounding part here, which is the solutions of hardening the system. We heard covered conductor, we heard undergrounding. I'd really like us to think about future construction techniques that really de-overhead the system, because you can cover a conductor, but you still have trouble if trees are going to come over and tip it to the line. Then you still have to rely on PSPS. Undergrounding kind of solves that problem because you go underground, but there is a cost, there is a high cost, and there's frankly topography that it's very difficult to be able to do undergrounding. If you get above the pine line, as they say, in the foothills, you often get into granite. And I've seen this construction where cable is constructed above grade, above ground. It's either encased in cement or it's in special conduits. We see it all the time on risers up the side of poles. It's not, unknown. And I think that we should be looking at revising the regulations in anticipation of these construction techniques, because we're going to be looking to go long distances in these areas. Load is often sparse and in between. And it can be cost prohibitive. And potentially, I think that these construction, well, I know I've seen them. They've operated for over decades, where they operate safely in these environments. So I don't see, it's all experimental now. New grade, above grade construction is under experimental rules, but I think that we should make a place for it in GO 95. And I think I will save the rest of my comments for the underground.
That's great. Thanks very much, John. Right, and we'll have our last panelist up now. It's Joseph Mitchell from MGRA. Joseph, please take the mic.
Good morning. Do you hear me?
Yes, I can hear you.
Okay, great. Yes, Joseph Mitchell, expert witness for the Mussey Grade Road Alliance. We've been involved in issues around and discussions around infrastructure and hardening and undergrounding for several years at the Commission and at OEIS. I'm going to primarily focus on covered conductor today, and I'm focusing on that because of its tremendous potential for wildfire risk reduction. When we look at the three major utilities in California now, one utility really stands out. In its 2023 WMP filings, Southern California Edison claimed to have deployed 2,900 miles of covered conductor and currently intends to deploy 1,250 more by 2028. Utilities have been working together on covered conductor. They have reached a consensus that its effectiveness in preventing wildfire ignitions is approximately 70%. However, if you look at the actual Edison data, and there's a lot of it now because there's a lot of covered conductor out there, in the most recent period, it appears that covered conductor is performing better than advertised. At the end of 2022, there had only been 3 wires down in the Edison area and no ignitions. Then this very wet winter came in and a lot of trees fell over, and that was some wires down. So in the end, Edison reported an additional 1 ignition and 13 wires down. Now, I did a comparison looking at what would the ordinary rates of wires down and ignitions be on unhardened Edison infrastructure. If we do this comparison, we would predict 27 wires down in the amount of conductor deployed by Edison, but in the covered conductor, only 16 were observed. We would expect 3 ignitions in that in that length of conductor, but only 1 was observed. So this is exciting. It's initial results, and we need to keep collecting this data, but it may be that we're getting more wildfire protection than we've been hoping for. Now, of course, it's not perfect. You heard some ignitions. PG&E has also deployed some covered conductor. It's had a couple of ignitions on covered conductor. So what have we learned about these ignitions that have happened so far on covered conductor? Well, all the same scenario. A tree falls over into the covered conductor, breaks the sheath, the conductor is exposed, comes in contact with vegetation and ignites it. Now, where this provides an opportunity is when we start talking about REFCL and other technologies. These low impedance faults and line breakage are exactly the types of signatures that new technologies such as REFCL, and for instance, with SDE, they've got their own falling conductor protection. These can de-energize the line before an ignition is likely to occur. So the technologies, we've talked about REFCL today, but there's a handful of these technologies. They should be supported, not just REFCL. So as far as new regulations, we would urge the regulators to encourage the acceleration of both deployment of covered conductor in conjunction with the protective technologies that can compensate for the limitations of the already very good covered conductor. And just one comment that Raymond made on, wind studies and climate change. I think another regulatory change you may want to initiate is just knowing that past patterns may not be completely representative of future patterns under climate change. So what that means is even if we can't really predict what they're going to be doing, we need to be constantly going back and checking and refreshing, remeasuring where are the winds, where are the extreme events occurring. So that's all I had to say. Thank you very much.
Thanks very much, Joseph. Very helpful insight there. Okay, so I'm now going to open it up for the public comment session, which will last about 10 minutes, although we're slightly ahead of schedule. Do we have anyone from the public who would like to contribute? Katie, I see your hand up. That was pretty quick.
Here, yeah.
Your name and who you're representing, and then provide your comment.
Yes, I'm sorry I didn't change my name on Zoom this morning yet. But my name is Katie Morsoni. I'm here on behalf of the Utility Reform Network, or TURN. And first off, I'd just like to thank Mr. Mitchell for his discussion of covered conductor and his attention to the successes of that and looking at the different ways that we can form it. I think that's a really important point to be made about these technologies. And I also think his comments really reflected what we were hearing from utilities, which is the solution to, not the solution, but successful wildfire mitigation is about relying on the diversity of our solutions and mitigations. It's not about one technology, rather it's about relying on different types of technologies and investments based on the local conditions and based on also the grid operations tools that you have available to you. And I just wanted to highlight, one other aspect of this that, is probably more in the CPUC's bailiwick, but I think is really important to think about when we're thinking about how we're changing regulations and the importance for making regulations that provide for a diversity of solutions is the cost effectiveness of the different mitigations, and comparing not just what one mitigation by itself could do in a location, but also, what undergrounding versus covered conductor and these other variety of technologies that are available, and really making sure that we are keeping rates affordable and achieving our wildfire goals and the most affordable way. I think we all know that electric rates in California are high and they're getting higher. And so we need to make sure that the solutions that we pursue as we rebuild our grid, as Mr. Branch has put it yesterday, are rebuilding our grid in the most cost-effective way to limit the rate shock that our customers are going to be seeing. Thank you.
Thanks very much, Katie. Do we have any further comments from anyone? Oh, Andy from PG&E.
Yeah, thank you, Lucy, and thank you, Katie, for those comments. I think reflecting what John Mader has said, what Matt Bender and Ray Fougere have said, as well as Dr. Mitchell. When I look at this topic, there's three elements that, when I think about the regulation, that I feel needs to be reflected, which is not reflected today. On the grid operations side, I don't think the regulations in California have kept up with the need to operate the grid differently and support PSPS and support the deployment of things like fast trip or EPS as PG&E labels it. There's still a reluctance to say that you're doing that, and while we agree there's wildfire protection being enabled, it's coming at a cost of public safety. And that is a false narrative from my perspective. You're protecting against wildfire safety, and what the regulations need to guide towards is, as you need to do that, show exactly what you're doing with regards to reducing the reliability impact of those deployments, those operational mitigations. Now, the reason for that is because those operational mitigations can provide protection over the entire grid very, very quickly, and we need the short-term protection now. Sorry for my cough. And we've seen some of that in play. The topics that Green Grid has brought up with regards to deployment of sectionalizing devices. PG&E has aggressively done sectionalizing devices on sections that we've seen PSPS events take place, and continuing that same logic, doing it on sections that have EPS as protection. With regards to the use of technologies, right, REFCO, the consideration that we need to give with REFCO and others is, how do we maximize the use of the existing infrastructure that exists to provide us that protection? Because REFCO is very good, but REFCO requires you to rebuild a section. It requires you to add a lot more equipment. How do you take the equipment you currently have and cost effectively use it for the operational mitigation? So that's the regulations around guiding the operations of the grid in the near term and providing the protection in the near term. In the long term, because the resilience work now, on the resilience works, the regulations do need to push aggressively and really support the rebuild of the resilience in some specific areas. And I think it's come up is like there are critical customers, hospitals, other situations, provide that support aggressively to those areas too, so that those areas get worked. And those areas, as they get worked specifically with things like non-exempt equipment, making sure there's conductor replacement to get that done appropriately, but also taking the local topography and what are the full range of extreme weather events that might happen and factor those in, because those extreme range of weather events, it does no good to protect it against wildfire risk, and the line comes down and has to get rebuilt because of a massive snowstorm and snow loading and issues like that. Now you can harden that equipment, but it's still, it comes down with wind speeds and with temperatures. So I think that balance. And then lastly, on the new construction, I think enough has been said, but the flexibility to maximize the use of new construction and not be hardwired into, hey, completely undergrounded. I think, John Mader, who's mentioned, like, run it parallel, run it above ground in a concrete, the construction methods, just open up the flexibility in the regulations to incentivize the maximum use of that as appropriate for the most cost-effective solution for the long term. Those are my comments.
Thank you very much, Andy. I think John Mader from the WSAB would like to provide some further comments. John.
Yeah, I'd like to respond, and I didn't bring up all this concept because we're talking about a change in regulations, which is basically it's a construction manual / maintenance manual, right? It doesn't go too much into operations, but I saw how as an industry, we kind of responded initially to the wildfires. As a capacity problem, we needed to go from a legacy system, which was susceptible to wildfire starts, to a system that was hardened and would not be subject to that. And the problem with that is it's going to take decades for that to happen. So we're going to be in a state where we're going to continue to have a system that is going to need to be subject to PSPS events or to quick settings that shut down power to large groups of people because they want to minimize the amount of energy into a fault. And so I thought of this from the very beginning, not really as a capacity problem, though. It's a reliability problem because we're going to be shutting down the power. And what do you do when you have a reliability problem? Well, normally you're like, okay, if I lose this one piece of equipment, what do I do, right? Unfortunately, we're in a situation where we lose all the pieces of equipment when you shut down the power. And so in that situation, you have to start thinking about designing your system so that you can start to minimize the amount of equipment that you need to shut down, or that you're able to start restoring it and get the largest return of customer, or restore the largest amount of power possible for the minimum amount of effort to speed up the reduction. So when Matt was talking about how these are all interdependent problems, if we can start doing the planning where we can point our undergrounding or our de-overheading to areas where maybe they're served by transmission towers that aren't going to be subject to PSPS events, so that we can get urban centers in these high fire district areas where we can leave those as much as possible in power. Now that's a little challenge to put into a regulation for GO95, but because it really doesn't go into how to operate the system. But I think that's the philosophy that we should be looking at, is bringing the maximum amount of value, and we're going to need some innovation to do that. And so we are going to need regulations that embrace that innovation and make it possible for these solutions to be developed. And that's what all I have right now.
Thanks very much, John. Any further comments from anyone on these topics, new construction, system hardening and grid operations, specifically on the questions, the discussion that the Green Grid presentations raised? I'll just leave it a minute, see if anybody would like to contribute. If there are no further,
we do have a hand raised from Wendy Al-Muqdad.
Oh, okay. So we've got two. Well, why don't we go to Wendy? Why don't you go first, and then we'll go to the Director Caroline Thomas Jacob.
Okay, can you hear me?
Yes. Thank you.
I have a question for Ray from Edison. This is Wendy Al-Muqdad with the CPUC's Safety Policy Division. I was wondering if Ray could talk a little bit more about the results of the wind study that was done before. And I believe there was like 5 different levels of loading rather than just the light and heavy loading. Can you kind of speak a little bit more and enlighten all of us of what that results of that study before and how you applied it?
Certainly. So yes, so our wind study came up with 3 additional wind criteria that we use for our design of structures. And those additional wind pressures, because the general order talks about wind pressures, were 12, 18, and 24 wind pound areas. And so that's kind of what the results of the study were. How we implemented this is we break our service territory up into grids. And so how we picked the wind load for that grid was we looked at what was the maximum wind pressure that we found in that grid, and we applied it to that grid. So if the wind pressure from the study said 11 pounds, we would round it up to 12. Or if it said 15, we'd round it up to 18. We weren't going downward, we'd always go upward, and it trumped at 24. So how we utilize this is every pole in our service territory, we conducted a pole load to those new wind pressures. And poles that didn't meet those design standards, we proactively replaced to harden the grid. And we've seen benefits from this because we have seen less failures from our poles failing during wind events. So we have seen just natural benefits. That's kind of the result. So we are redoing that study now. It's in process. So this could change because obviously we have a lot more weather stations. We'll have access to more information. So we're going to see what the results say. Some areas could go up, some areas could go down. Don't know, letting data drive it. They haven't shown me anything yet, but that's how we utilized it.
Great, thanks, Ray. Thanks, Wendy. Caroline, did you have an additional comment from your side?
I do. I have a question, and I wanted to build off of something that Board Member Mader brought up. And I was wondering if any of the utility representatives or stakeholders or panelists that are on the line could speak to life cycle management. So I know that it was commented on that age is, not a single factor that should be solely relied on, but maybe one of many. Could the experts talk a little bit about life cycle management in the sense of the usage of components? So say a component is lightly used, it could potentially last longer versus if it happens to be in a configuration where it's heavily used, it's then going to have a shorter life cycle. Could the experts maybe speak a little bit about that in terms of current regulation and potential opportunities?
Great, thanks for the question. Andy, you've switched your video on. Are you willing to provide a response?
Sure, I'll be willing to provide. I think John Mader, given his expertise, may want to go first. So I'll let him kind of go first if he would like to comment first.
Well, I particularly fixed and concentrated at the WCB on seeking ways to address equipment that's pre-GEO 95. I've made several recommendations. One of them has been adopted. Basically when pre-GEO 95 equipment is the quality control check is the inspection process. It's a qualified electrical worker goes out, observes it, and says, okay, it looks like it's okay. There are other factors, though, that are not really in the purview or the training of a qualified electrical worker. Engineering factors, I think, that should be evaluated. There are some equipment that I've seen that is, nearly from the, could have been installed by Tesla practically, and it's in fine operating shape, and it's still capable of performing adequately. But I think, given that the campfire was the result of pre-GEO 95 equipment, it obviously subject to the towers shifted and moved, and they changed the state of the loading on the wires and relative to each other, something that a qualified electrical worker is not going to be able to visualize and see that kind of change. I do think that the regulation should require some sort of review. I don't think that it should be that one answer fits every problem, but I think that there should be some sort of an engineering review of equipment that is pre-GEO 95, because we know how it's been maintained or how it was constructed if it's done afterwards, and we have information and we've got performance information on that. We just don't for this type of equipment. So I do think that there's a place for calling for an enhanced study on that equipment. Once again, I'm going to go a little bit into the undergrounding. I do think that construction standards for undergrounding should be required, that those cables are able to be economically replaced direct buried, for instance, should be prohibited. There should be some sort of conduit system, some sort of pull length, or that makes it possible for equipment to be replaced in an economic manner. Because, I mean, cable tends to have, especially underground stuff, 25 years or so. We can have a ticking time bomb if we replace everything with a system that we have to go back and redig and do everything. So I do think that there should be construction standards for looking at how to maintain the system for the life cycle of its of the equipment.
Thanks, John. And the next session after our break is going to be underground, and so
yeah, I pretty much talked about all I'm going to talk about on that already. Yeah.
All right, brilliant. Thanks, Andy. Is there anything you'd like to say in the last couple of minutes of this part of the workshop?
Yeah, I would like to, addressing Director Thomas's question, right? How do we take the life cycle costs into consideration regarding in these standards, right? I think life cycle costs should be given consideration, partly because from a degradation perspective, I don't think it's purely the load profile and the variations in load profile that degrade the equipment. I think in the high fire threat districts in these territories, at least we see in Northern California, the extreme weather events combined with the loading have and accelerate in some cases the degradation, but the degradation is not uniform, and it's very hard to really address and develop those patterns of degradation. And so in lieu of that, right, I think what you do is you try to over-engineer the system such that it can withstand a much higher. So the guidance is in areas of high wind loading, as Mr. Frigier was talking about. You could certainly change the design criteria to withstand that and overcome the life cycle cost of failure. But I think it really comes down to the inspection aspect of it. How do you go about put some type of real-time monitoring inspections on the system for the electrical portion? And then how do you do the inspection of the structure portion of that asset in two different mechanisms? Because the electrical portion, a lot of times, it's hard to see the degradation from a qualified electrical worker doing a visual inspection. You have to put different, and the flexibility that we need to build in the regulations around inspections is critical there. So I just want to kind of put that out. That's how you get to finding out where the imminent fault may happen. And then once you've got that imminent fault projected, you can go take proactive steps, because the age alone will not tell you that. Now, to Director Thomas's his point, the reason why, at least on our perspective, why in a lot of cases undergrounding makes sense is because you've got a really high degree of vegetation, and then you've got that O&M cost of constantly patrolling the line and checking the line, not just for vegetation, but for inspections. And if you can take that line out of service, none of those O&M costs go down, making the life cycle significantly cheaper over time. And so that's one of the factors we weigh into our decision-making process. And the regulations should ask us to consider that.
Thanks very much, Andy. And Ray, you've turned your camera on. Would you like to contribute to this?
I just wanted to say I really agree with what Andy said. When we're looking at it, it isn't just age. And really, as we shift for assets to stay overhead, this is why we're looking at new technologies, early fault detection, other things, get real-time monitoring. So we're not just relying on the engineers or the inspectors, but relying on information real-time to find those failures before they actually, the kind of like the pre-failure before it becomes a fault condition. And that's really what the next step is. And that will drive your replacement or your maintenance, instead of just having to have a cyclical inspection, but having real-time monitoring. That's really where, the next step will be in the utility industry, not just for wildfires, but also as we push for more electrification. That's what's really going to be needed to get that reliability up, because replacing something before it fails, it's more beneficial to our customers. We can plan around it. So there's all these other things. Also, I just want to say I agree on not doing direct buried cable. When I look at undergrounding, there's a thing that I say, cheap is expensive is kind of a motto that I live by on a lot of things. It would be cheap now, but it'll be very expensive in the long run. So I fully agree with that. We should really stay away from direct buried cable. Maybe there are some very small isolated segments, if it's a small lateral, but for the main conduits are the way to go. So just want to point that out, that I agree fully with that statement.
Great. Well, thank you very much, Ray. And, you know, as I said, we've got undergrounding after the break that comes just before lunch. So since we're at time, I will call a 10-minute break unless there are any burning questions. I don't see any hands up. So we'll go into our 10-minute break now and we'll return at 10:53. Welcome back from the break. Right, the next topic is undergrounding, and we're going to kick off with the Green Grid presentation from Eric Pessimer. Eric, over to you.
Awesome. Thank you, Lucy. Welcome back again. I am Eric Pessimer, Senior Project Engineer at Green Grid. Currently, the focus of our discussion is undergrounding. Next slide, please. Physical relocation of electrical line to underground can potentially reduce ignition risk from electrical distribution equipment and structure. According to observation, by relocating existing overhead line to underground, ignition risk is reduced by a significant amount. Underground mitigation is a technique that helps to lessen the risk faced by climate change. It can help prevent incidents such as face-to-face contact, equipment failure, and damage caused by extreme weather conditions. This method increases safety and reliability. Next slide, please. Based on our observation, there are provisions in place for construction, maintenance, and environmental conditions related to underground activities. However, there is room for improvement in making the regulation more specific. Regarding construction, the provision emphasizes good practice, safety of workers and the public, preservation of property. For maintenance, the focus is on ensuring safety of workers and the general public. In terms of environmental condition, the provision include location, safe access, maintenance, and avoiding interference with traffic, and among other things. Next slide, please. As we discuss wildfire prevention, we highly value the input of all stakeholders. Considering the environmental circumstances, we aim to address regulation related to a specific topic. To prevent or reduce wildfire, it is important to take into account various factors such as environmental, social aspects, and infrastructure. Next slide, please. Discussion point 2 geared towards construction. When it comes to construction, there are several phases to keep in mind. These include environmental assessment, land survey, geotechnical soil analysis, and design. Additionally, there may be unexpected issues that can arise after construction, such as asset corrosion, soil erosion, soil type variation, and existing subsurface utility. Fortunately, there are measures that can be taken to reduce these challenges. Factors to consider include heat dissipation, environmental assessment, geotechnical soil testing, soil corrosion and erosion prevention, customized construction method. Next slide, please. Discussion point 3, utilizing modern techniques, new and improved method for construction. There are a few different techniques that can be used depending on location of construction. Horizontal directional drilling is a good option for area like water crossing, where there are environmental concerns around railway and highway crossing. Mechanical excavation is best for rural area and non-improved road, as well as area with underground conflict involving third parties. In urban area and on improved right-of-way, the vibratory plow is a good option. Innovation in material and equipment. There are few material and equipment options that can improve the construction process. The cable and conduit offer enhanced protection, streamlined installation, and durability. HDPE conduit is flexible, durable, corrosion resistant. Fault indicators are also available, which can identify fault location, improve reliability, and enable faster restoration. Next slide, please. Discussion point 4, maintenance revamping. To ensure system is running smoothly and effectively, there is a maintenance protocol in place. However, it may be beneficial to revamp the maintenance process to align with the current electrical infrastructure. This could involve conducting voltage tests on cable shelf, inspecting tunnel and transition station, inspecting utility hole and joint pit, inspecting cable routes and crossing, and also securing pad mount equipment. Next slide, please. Discussion point 5, pros and cons of undergrounding. As we all know, there are pros and cons with everything. Undergrounding is no exception. Making our system safer and more resilient to address the changing climate, it is possible through undergrounding, but it comes with challenges such as high installation costs, cable deterioration, service disruption, cable failure, and slow deployment. However, there are also potential opportunities to consider, including cost reduction strategy, cable quality improvement, minimize service disruption strategy, efficient repair process, and improved deployments. Additional benefits of undergrounding include fewer emergency restoration activities during extreme weather conditions, and also less vegetation management activities. Next, please. I will now pass it on to Lucy to invite our panelists to open discussion. Thank you.
Thanks very much, Eric. Okay, so we have 4 panelists involved in this discussion, and the first to start us off is Matt from PG&E.
Yes, thank you, and thanks for that level setting, Eric. So a lot of this is related to what we talked about earlier, and John Mader started bringing in some of the concepts that are undergrounding specific to the system hardening discussion. And I think that's appropriate because they are related, right? We're not doing undergrounding in a silo and system hardening grid operations in another silo. It's all an integrated approach to reducing wildfire risk. One of the last things Eric said there is that there's pros and cons to everything, including undergrounding, and that's absolutely true. And our goal as utility and where we can all help as a community is to maximize the pros and minimize the cons, right? So one of the pros, one of the benefits to undergrounding is that we very much expect to have improved reliability performance, less outages, right? It's less exposed to the weather factors and things of that nature, so we should have fewer outages. And so how can we continue to grow that benefit, including by doing cable commissioning testing or things of that nature up front to make sure that the asset will maintain its serviceability and reliability for a long period of time. So how do we maximize the benefits that we already know are inherent in undergrounding? And then how do we minimize the negatives, the cons? One of the cons is that it costs more upfront on a per mile basis. And so anything we can do to make sure that we have the flexibility to deploy the best undergrounding solution for each area is important. The construction methods were mentioned on one of the slides up there, including like horizontal directional drilling, which is an important tool to go underwater crossings or avoid environmentally sensitive areas. And then other tools, rock wheels, chain trenchers, etc., in wide open spaces where there aren't environmental sensitivities can really provide a lot of benefit in terms of cost efficiency. So similar to what we talked about in system hardening, having the flexibility to apply the right solution in terms of construction methods, in terms of the actual asset installed, is really important. There was a discussion this morning about, in the previous discussion time, about direct buried cables. PG&E is not doing direct buried cables at this time. It's something that everyone should continue to monitor as the technology for the current cables is significantly different than what we have installed in the past and have experience with, right? So the experience that us and many other utilities have with undergrounding is largely in urban areas and is largely with the underground cable technology from 30, 40 years ago, which has changed a lot to what we're using right now. And so that's where, again, flexibility to try the latest tools and technologies to figure out what is going to be most cost effective for getting us those benefits at the most affordable investment upfront. Relatedly, being able to efficiently acquire, because this work is so much more intensive, being able to acquire the permits we need, getting alignment with the customers and communities that we're working with is really important and more complex for this kind of work than overhead hardening or other solutions we talked about this morning. So that's something important to keep in mind throughout this, is that the audience of folks who are very interested in exactly how undergrounding is going to be done is broader than maybe for overhead hardening and things of that nature. Another point on that is about joint pole and other utilities on our poles. So telecom, cable companies, for example, they are largely to date not incented or interested in joining us in the underground trench, which is, currently their prerogative. But we've experienced less desirable from the community's perspective. The community would prefer to see all utilities go into the trench. And it does continue to leave a pole standing overhead. It may not no longer be owned, or the electric utility may no longer have any interest in that pole, but it needs to stay for the telecom company. And that, has negative outcomes as compared to being able to remove the poles. So that's another area for this community to think about, is how do we incentivize the joint pole tenants or joint pole partners to be interested in undergrounding as well. And then the last thing is a repeat from this morning, but I'll say it again anyway. Flexibility and interest in exploring new tools and technologies. John Mader mentioned it earlier this morning about level grounded or ground level systems in super hard rock or other complex terrain, being able to deploy a system in an encased, protected package, but without burying it 30 or 24 or 36 inches, has significant benefits in terms of the cost and flexibility of the system, and therefore benefits to our customers. And so making sure that as we think about any adjustments to regulation or monitoring, that we keep our minds open to changes going forward. Or the latest technologies. So I'll end it there and pass it on to the next person.
Thanks very much, Matt. Next up, we have Lynette Aquino from SDG&E. Lynette. Rain, can you see if Lynette is on the line?
Seems like there is a communication from Lynette that she has an emergency. She had to drop up.
Oh, yes, you're right. Okay. All right, then we'll move on to the next panelist, who's John Mader from the Wildfire Safety Advisory Board. John, is there anything you'd like to add? I know that you've already spoken about undergrounding a little bit, so no need to repeat that, but if there's anything you'd like to emphasize or to add to your comments on undergrounding, that would be
I know you want to go to lunch, but I am going to repeat a little something, okay? which just to put an illustrative point, right, which is that the Dixie Fire started when a tree tipped over into overhead lines going up a cliff, right? It was very steep, and could you imagine, there's no at all foot traffic there. Could you imagine if that had been above ground, de-overheaded construction? That simply wouldn't have happened. That simply wouldn't have been a possibility. It would have been impossible to trench a cable up that cliff, but it would have been very possible to put, as Matt points out, a cable inside of some sort of protected armored structure, and it would have been cost effective. And so that's from the like visceral advantages you can see from the concept of de-overheading or above grade construction. The other thing I wanted to say was my point about that construction standards should have anticipate replacement of equipment in the future, so they're economic. There is new technologies. I think Matt is referencing new technologies about direct buried, but it comes inside of like a ready conduit, so that you're able to replace the cable in the future if it's when it needs to be replaced. So my point isn't really like absolutely never, but we need to solve the problem of being able to economically replace that equipment at the end of its lifespan. And then generally I'll speak on the concept of, the reliability increase that you receive from, and this isn't really a regulatory comment, but it's something I say this everywhere I go, right? Which is the advantages that you get, the reliability advantages that you get from underground include the fact that, hey, when you have a red flag day, you need to do a PSPS event. You don't have to do that for underground. However, if the underground is fed by an asset that is subject to PSPS, then it's just as susceptible to PSPS as if though it was an overhead construction, really, because you have to shut off the source and that interrupts the power flow. So it really takes that integration of all these different resources and figuring out where to put them first to get the most bang for the buck, so that you can leave those people, those communities in power. So that they can be, in essence, an isolated little grid, so that people don't have to drive 2 hours to get ice. They can drive only a half hour inside their own in their own counties to be able to get supplies. And considering the impact that some of these PSPS can have, that can make a huge impact on the quality of life in these communities that are subject to PSPS. Yep.
Great, thanks very much, John. Tyson, you've got your hand up. Did you have a specific comment? Are you from SDG&E?
Yes, I'm from SDG&E and can just add a few more comments with Lynette dropping off, just to be able to talk about underground. A lot of great things already been said, and I just want to add a few things. We talk about the pros and cons of undergrounding. I just don't think it can be overstated the value of the. We talked about improved reliability, less vegetation management costs. The main value, though, is it's quite nearly 100% mitigation against wildfires. Since we've been tracking ignition sources, I think we've had one on a vehicle contact of pad-mounted equipment. Most of the types of failures you get, cable failures or underground failures, they're happening, underground in a vault, or to John's point, could occur, in an above ground concrete package. But again, the fault location is going to be contained. There is no ignition source with that. I know Caroline had mentioned life cycles of efforts, and there's a lot of good talk about how you can kind of mitigate overhead construction, like the failures as those age through inspections. And there's amazing technology going on right now on the electrical side to be able to proactively look at essentially power quality signatures to try to predict failures before they happen and to identify where those are and really try to avoid those ignitions as equipment ages. But again, one of the main values of undergrounding is as we do hit the aging assets in the current state with the current technologies we have, as systems age, we do see increased failure rates. So it can be a tough thing 50 years down the road from now when we've hardened all this overhead infrastructure. Are we starting to see, even with all the technology and all of the work we're doing through inspections to try to identify and be proactive and not allow these failures to happen and not have that potential ignition source with underground? If those failures do happen, there's no ignition consequence. We can go out, again, cable and conduit. We talked about that. We can replace the cable and conduit. We go out, make the repairs, and there's still no wildfire risk. So from kind of a longevity to stand the test of time, at least for wildfire, even when underground systems begin to fail, we're not going to see that same level of wildfire risk. I do appreciate the comments, though, on flexibility. I think that's really important. There just are areas where it's not feasible. The cost differences in solutions are so substantial that you have to evaluate whatever your best option is for the area. And then, but really liked all the comments around, what are, kind of out of the box solutions with undergrounding. Can we leverage the benefits of undergrounding while mitigating some of the costs? I think there's a lot to explore there and look at through this process. Thank you.
Great. Thanks very much, Tyson. I appreciate you stepping in for Lynette with no notice. We have one final panelist, Joseph Mitchell from MGRA. Joseph, would you like to provide your feedback on this topic?
Yes, thank you. Since PG&E originally came up with its major undergrounding proposal, what we've seen in the WMPs and the rate cases is that undergrounding is now being considered a default option for hardening by the utilities. They will propose undergrounding unless there's an obvious reason not to do undergrounding. In addition, we've now got pending action from SB 884, 10-year undergrounding plans. But it is important to realize that an important component of that bill that both energy safety and the commission will have to deal with is that it requires undergrounding to be compared against potentially more cost-effective alternatives. Now, energy safety's mandate is safety. The commission also, the CPUC also has the obligation to ensure that rates are affordable. And undergrounding is still the most expensive option, $2 million per mile, $4 million per mile. Maybe some of these things that people are discussing could bump that down a little bit. But if you look at the scale of the utility wildfire problem, the high fire threat districts, if all the higher fire threat districts were to be treated with undergrounding, you could see a total cost of that exceeding $100 billion. Now, California is going to have to spend a lot of money for climate adaptation. And we shouldn't have to bury all of that climate adaptation money in one place. We need more efficient options. So one of the things that I have put into our filings with the WMPs is an observation that we made using epidemiological data on human life expectancy. And it's the dependency on income. And what we found is that when you look at the rate increases that are necessary and to support these major undergrounding programs, it's enough to move those curves so that people are living less long for one reason or another. Maybe one person can't afford their rent, another person can't afford their medicine, just big effects over the poorest segment of the population. So as we make California safer, we have to ensure that we're not just shifting risk from people living on the wildland urban interface, as I do and my family and community do, and shift that on to the poor and vulnerable in California. Now, from a regulatory standpoint, what does this mean? It means that making sure utility wildfire mitigations are cost effective, including full cost benefits, including human impacts. Undergrounding is very effective. Nobody argues with that. However, combinations of covered conductor along with these advanced technologies and a limited power shutoff approach, and limited, I mean, at higher thresholds because you've got a more robust system, and taking the thresholds up reduces the area that's affected. It reduces the duration. So that would decrease any impacts from PSPS. These might be ultimately a better solution. Another quick comment, as we've seen recently, climate changes are coming upon us very dramatically. And it's important that mitigations be implemented as soon as possible. Undergrounding, for a number of reasons, is also the slowest option to implement. Southern California Edison has shown it's possible to deploy hundreds of miles of covered conductor per year. So I think regulators should also ensure that whatever mitigations are chosen to be implementable in a reduced timeline as fast as possible to protect people in the vulnerable areas. Thank you.
Thanks very much, Joseph. I want to open it up now for the public comments. Do we have anyone who wants to participate in this? Katie, you were quick again, off the mark.
What can I say? 3 years of Zoom, I'm pretty good at the raise hand function. I actually have two questions rather than a comment, and I'm gonna, I think, pose one and get the answer, and then if I can have an opportunity to ask my second question, that would be great. And my first question was for Mr. Pender, or one of the other utility representatives that was discussing the use of conduits for their undergrounding. Mr. Pender was discussing the problem of certain other utility, like the telecom utility, staying on the pole. I guess I had a question about the ability to future-proof a bit here. Like, is there a possibility of, by using conduits of a bigger size than is necessary strictly for the electric utilities, that you can maintain space for telecoms that may make a different decision in the future? Or is that just not how the technology works? Reminder, I am not a technical person, so it's really just a question.
Yeah, it's actually a fantastic question. It gets to kind of a in the weeds item that may actually be worth this process looking at, which is the regulations right now. The general order requires that if we put telecom conduit in the same trench, it needs to be separated vertically from the electric conduit, right? And so that actually makes it more expensive. The whole trench has to be a little bit deeper because we're putting both telecom and electric in the trench. Now, so we can do that, right? And we can put in an extra conduit that the telecom could take over either immediately or at some point in the future, but it would make the trench more expensive. There is like one sentence in GO 128, I think, that says that by mutual agreement, that separation can be reduced, and that would allow the whole trench to be less deep. And the benefit of that is cost savings up front, while still future-proofing, having that flexibility for the telecom company to join the trench. Nonetheless, adding that extra conduit, whether we have to add depth to the trench or not, is an incremental cost, maybe not significant, but unless there is some reason to believe or assurance or support for the telecoms to take advantage of that extra conduit and join the trench, it would, may not be the right investment for the utility and therefore our ratepayers to put that in up front. So yes, there is the opportunity to move in that direction to future-proof, but we would like to think that there is a structure in place to encourage the telecom companies to take advantage of that asset if we were to invest in creating it.
Thank you. And then another, I'm not a technical person question, to just kind of understand the impacts of these decisions. And this is for Mr. Pender or any of the other utility representatives. I understand that there's no ignition consequence for a failure of a line that has been undergrounded, but I guess it strikes me that isn't there a very large potential for a reliability consequence? It may not be that there's a PSPS, you may not be calling PSPSs more often, but if there is a failure or an outage of a line that's undergrounded, how involved is the work required to mitigate or fix those failures? And kind of what's that timing look like? Like how do you do that? If it's not just on the line above you where you can fix it, like how involved is it?
Yeah, great question. I can start and then any of the other utilities can jump in as well. So the dichotomy that has been thought of for many years in the utility industry is that underground assets fail less, but take longer to restore, whereas overhead assets fail more, have outages more, and are quicker to restore because you can just drive along and see where the problem is, and your troubleman can get up in his bucket and splice the cable together or fix the asset, whatever the case may be. To comment, so that is generally true. And so I'll explain why it takes longer to fix an underground asset, but the technology used in underground cables has substantially improved in the last 40 years since a lot of underground suburban subdivision systems were installed. And so we have high confidence that the assets we're installing now will be robust for a long time. And I'm sure the technology will continue to improve, but the underground assets we're installing now should be very strong. When underground systems fail, they most frequently fail at joints, where the cable is coming out of the ground and either going into a pad mount transformer or going into a joint so it can split off to multiple areas or something like that. The good news is those joints are in boxes, and so you can open the lid and get in there and fix what you need to fix. So the time to restore doesn't have to be that long, but 2-3 hours, is the kind of the way to think about an outage like that. If the cable itself fails inside the conduit, somewhere between this box and that box, box A and box B, that is the time. That is the kind of outage that takes a long time, many hours to restore. And the way that we would repair it, if we have it in a conduit, is to just pull the bad cable that failed out. So clip it at one box, pull it out, and pull a brand new cable in, and then join that, splice that cable to the existing system. That is, doable when you have a conduit system, which is why the guys this morning mentioned that they don't support direct bury. They want to see all of our underground cables inside conduits. But that's still a more time-consuming repair. So kind of threw a lot of stuff. I hope I wasn't too technical. Did that make sense, Katie?
It did. And for the proposal that Mr. Mader had regarding the, what I have simplified in my brain to be concrete boxes laying on top of the ground.
Yes.
That is a conduit covered by a concrete box. So it would be a similar process.
Yeah, I don't recall exactly. I believe, yes, you can pull the cable through that. But also because it's right on the ground, if we needed to, we could just jackhammer out a section of that concrete box, if you will. But John, you're raising your hand.
Yeah, there are at least 3 different construction techniques that I know of right now. One is they've got a ready tray that they put a top on and they can bolt it down. So it's actually some sort of fiberglass armored carrier that's just above ground. I've seen where they're using concrete, like the K-rails, miniature K-rails that they have between freeways that make it hard to crush because they push your car away. I've seen things like that. I've seen also a conduit going from stanchion to stanchion to stanchion to stanchion, right? So and then there's got to be tons of different engineering techniques that people will come up with that will be interesting and potentially more effective. One of the advantages of above grade construction is it potentially makes it so that you don't have to use underground boxes to do all these connections that Matt's talking about. You could actually have pad mounted connection boxes, which you see the reason why those boxes have to be so large is you have to get personnel in there. You have to get pulling equipment in there. They have to be way larger than they need to be in a normal situation, where that's not the case if you're using some sort of pad mounted or above grade, like enclosed, protected, and it can be much smaller, require much less land rights. You've got less problems with people building over it. Of course, it's really not good for areas that have high foot traffic or driving traffic. I really kind of think that this is going to be for up in those granite areas predominantly, where you're serving a bunch of campsites. What difference is it? No one's, and the deer can step over it. It's not going to be a big deal. That's how I see that working.
Great, thank you for that. Kate, are you happy with the answer to both of your questions?
Yeah, thank you for your very clear explanations.
Next person who has their hand up is Zoe Harold from Green Power Institute. Zoe, thanks for waiting.
Yeah, thanks so much. Thanks, Katie. Those are great questions also. So I have 2 questions and a comment. So if someone else raises their hand, I can take a pause. But I'll start with the decrease in operations and maintenance costs. So my question is, what we've seen even from, some of PG&E's kind of informational documentation is that we might be undergrounding the primary distribution lines, but not secondary and not service drops. And so as well as what we've heard today, which, there's also telecommunication cables that are using those poles. And so my question is kind of what what extent will the poles likely remain in place with current undergrounding plans, including secondary lines, service drops, and then with that exposure, how much are we still going to have to do all the inspections, all the vegetation management along those same lines, where that, you know, the vegetation management standards aren't going to change for these secondary lines because you're still going to, you know, cut back 12 feet and clear to the sky. You're still going to have to go have crews out there patrolling all these different lines. What's the extent of that ongoing exposure?
Yeah, so I can answer for PG&E and then others can chime in if they are interested. So vegetation management requirements for secondary and services, because they're substantially lower voltage, right? Generally household type voltage, are much different than the vegetation requirements for the mainline high voltage, 12 to 21 kV systems. And so the ongoing vegetation management costs associated with services and secondaries is relatively small, very small. And we recently analyzed it to be less than, in the vicinity of 2% of our annual vegetation management spend is on secondaries and services, right? And so so we still believe that undergrounding the main line and therefore avoiding the vegetation management costs associated with that is substantially beneficial. We are leaving the services overhead. That's our current strategy. But we are taking action to make them safer in that process, including installing breakaway connectors. So where the service leaves, like the riser pole, there's a breakaway connector. So if a tree falls across, it immediately disconnects and de-energizes before it hits the ground. And that is an enhanced layer of protection, even though the line itself hasn't been put underground. And so that's the wildfire risk. But you asked about cost or maintenance costs going forward. Poles that we own, like a service pole, we need to continue to inspect. So there will be an inspection cost. In areas that are not densely populated, we often have several mainline poles before we get to a service pole. None of those mainline poles will be needed for the utility any longer, right? And so a number of, maybe a majority of poles will come out of our maintenance program, as in we won't have assets on them anymore. We won't need to inspect them. I say it that way because whether they stay or not, whether the poles themselves remain in the air, will be driven by the presence of telecom or other joint pole owners who need to keep the pole, right? Do they need to, do they want to keep the pole because they have assets on them, in which case they would take over sole ownership of the pole. So we haven't done a lot of analysis of, like what percentage of existing poles will stay or not. It's very project specific based on if there are joint pole tenants or not. But that's how we think about the maintenance aspect of it is, we'd eliminate a number of them and then we'd have maybe one service pole that we need to continue to inspect. But the vegetation management cost will drop substantially.
And so is that part of the plan to kind of look at this full, life cycle cost? Because I think this really plays into Katie's earlier comments and Joe's comments, and really the climate adaptation decision, let's see, I believe it's D 1910-054, specifically retains strategic in the definition of what climate adaptation should follow. And that was left specifically in regards to looking at cost benefit analysis for planning and building facilities to operate under actual and changing conditions. So I think, it's a really kind of critical question that's raised in the climate adaptation proceeding, and also of course for the WMP proceeding. So so in question format, what's the plan, I guess, for looking at and doing the analysis of X number of poles are going to remain, these are our vegetation costs that are going to remain, vegetation management costs, factors like that.
So we have done a fair amount of that analysis. I mean, informed by studies and, samples of what we've done to date in terms of how much we believe the vegetation cost will change, i.e. go down once we've undergrounded the main line. And the reduction in inspections for the assets that we don't need anymore, namely the mainline poles. So we have that. We expect to continue to refine it based on our ongoing experience, right? We're going to underground more miles this year than we did the last 2 years. And so we'll continue to grow that sort of database of what actually happens, what poles do need to stay and what don't, what kind of equipment do we keep out there, et cetera. So what I would say is we've done that analysis. We're going to continue to refine and grow that analysis based on the latest and best data. And as different technologies play into this, like the level grounding stuff that we were talking about, that John talked about, that also changes it, right? How does that impact where we have pad mount equipment or other things that may drive costs? Because pad mount equipment I use as an example because we have to inspect it on an ongoing, like every 3 years basis. So the inspections may shift from all the overhead poles to a smaller number of pad mount equipment that is, on the surface of the earth. So we have that analysis and we'll continue to make it better.
Awesome. And then is part of that analysis also including any reliability impacts from switching to these like breakaway components for service drops and, kind of the impact there if we're doing less vegetation management, say on a pole that did have a primary line that got undergrounded, but we've still got secondaries and service drops, and now they're all breakaway. Are we going to have a lot of issues with that, cutting out power effectively?
Yeah, good question. We will continue to monitor for that. Again, we've modeled what we think, right? Which is that largely these breakaway connectors will make outages that would have happened anyway safer, right? Outages or ignition potential that would have occurred anyway safer because it'll disconnect the electrified line faster. But we will have to see if we experience any empirical results that are different from what we expected in terms of, are we having more outages on services that have breakaway connectors than similarly positioned existing services that don't. So yes, we've analyzed what we project right now and we'll keep growing it.
Great, thanks. And then do any of the other utilities, are they, working on similar kind of more holistic life cycle cost benefit analysis?
So we don't forget, we've got the asset inspections topic coming up after lunch. So
okay, great.
Considering the regulatory recommendations associated with that. Yeah, is there any other utilities who would like to jump in and make any comments? No.
So I'll ask my second question. So we also work on the high distributed energy resources proceeding, R2106-017, and that proceeding is looking at a lot of the distribution planning processes at the IOUs, and really, making sure that the grid is upgraded and prepared for this large influx of distributed energy resources, which include electric vehicles. So the, the increase in load expectation is pretty substantial and it's very patchy. So my question is how, with, kind of really large line rebuilds, like what the undergrounding program is doing, especially at PG&E, is there coordination or good coordination between the utility distribution planning group as well as the wildfire mitigation and essentially system hardening design group in terms of making sure that these new systems are adequately built out and prepared to also provide service for increasing load?
Yeah, again, I'll go first and others can jump in. So the short answer is yes, there is strong integration between our distribution system planning and modeling team in terms of what they model for future growth and the design teams, the scoping and design teams for our undergrounding projects. In general, that we are upsizing our system when we put it underground for the future growth, even though a lot of these areas aren't currently forecasted for substantial growth for a couple of reasons. Number one, you mentioned that kind of growth is expected to be very patchy. There are income related, tends to be higher in certain areas. Electric demand will grow in higher income areas, maybe more than others. And then just the density, right? Because these are rural areas for the most part with spread out customers, that doesn't have such a density of load that it, is forecasting a ton of growth. But we are definitely sizing it for current load and sort of known future or near-term projected future growth. The one area that we've gotten into some difficult conversations is about hypothetical future growth, sort of level 2. What if it really took off out there? And in some cases, our distribution planning engineers have said, hey, we'd like to just put an extra conduit out there, an empty extra conduit that we could run another cable through someday. And in many cases, we do that because it makes sense. We've already got the trench open. It's not a big deal. In some cases, it's very expensive to add that extra conduit. As an example, if we have a water crossing, we have to bore under the water crossing, use a horizontal directional drill to go under and pop out the other side. And you generally have to do that for each conduit. And so putting in a second one is 2x the labor and cost to put in that second conduit. And so those are the ones that we've wrestled with. How much do we spend extra, maybe double the cost per foot right now to put in that second conduit for hypothetical potential future growth, right? With the understanding that construction method is still available to us in the future. Like, since we have to bore this one, you could always come out there in 20 years and bore in another conduit if it became necessary. So it's not a super simple all the time we're upsizing it 10x, right? We're upsizing it for known growth right now, and we are considering the hypothetical future growth, and where it's cost effective, we definitely put that in. Where it's not cost effective, we're wrestling with it. In some cases, choosing not to put in that empty extra conduit for the just in case scenario.
Great, thanks so much.
Excellent, thanks very much. So we're scheduled for a lunch break now, but I just want to check whether there are any questions before we finish this section on undergrounding. Any final questions before lunch? And Rain, please let me know if I'm missing any raised hands. No? Well, that means we're...
Nope, sorry, hold on. We do have a raised hand from Wendy Al-Muqdad.
Oh, great, Wendy.
Hi, yes, you can hear me?
Yes, we can.
Okay, great. I just want to ask about the new technology that John Mader and PG&E reference about the above ground lines. We did a data request, and PG&E only has a mile that it seems like it's very much in an R&D phase right now. So my concern is that when we're talking about this, it seems to me that this is a very long-term prospect and not really that feasible for the next 5 years, say. And so I just wanted to get others' input. Am I understanding that correctly?
So I'll go, and then I suspect John may have an opinion because he's keen on this as well. You're accurate about where we're at, right? We are piloting about a 1 mile project with this equipment from a vendor who's developed it and tested it and all that kind of stuff. We're doing about 1 mile this year. We don't expect it to be ready to scale in the next 2 or 3 or maybe 5 years in terms of it wouldn't be ready for 100 miles or things like that, but it might be ready for some really critical, valuable miles, some extremely difficult to dig in miles. And so even if it's only 3 miles, 10 miles, 15 miles per year, that could have a significant impact on reducing the cost of the most expensive miles by using this technology, to our customers. And so we don't know, right? Because it's in a developmental stage. And so in the long run, in 10 years, is this going to be a massive part of the solution, or still just a tool for specific narrow applications? We don't know, because we're just testing it out. But that is, but you're accurate about where we're at, which is early in the process of understanding exactly how this tool can help us.
Well, and I would say that, there's going they're going to have to be construction techniques. They're going to need to be developed. Those, you know, civil with a PE is going to be able to design structures and going to be able to look at, you know, how to put anchors in the ground. You can foresee how that's going to go and how that will develop. But what I think is what I'm concerned about, and I think it might even take longer, is regulatory acceptance. Is communities, national forests, reservations. I think that the more we can do to get the public discussion to become so folks can start to see the potential benefit. Because I mean, my gut tells me, and my gut's pretty well informed on these things, that we're probably looking at like maybe 15%. And what concentrated in some of the hardest, most expensive areas to underground, or even put in overhead. I mean, there are places where you have to blast to put in holes to be able to put in poles. You know, this kind of construction would be ideal for that.
Great, thanks very much, Wendy. I hope that answers your question. Any further questions before we finish for lunch?
We do have a hand raised from Henry Sweat.
Oh yeah, Henry from the CPC, please go ahead.
Thank you. Yeah, Henry Sweat, CPUC, Safety Policy Division. Just on the above ground thing, I didn't hear you mention drainage. I think making sure that those don't become a mini little dam on the side of the road is important. On my two questions are, for the underground vaults, I'm under the impression there's been a couple of fires in underground vaults in San Francisco. I understand that's probably a really different technology, age, asset range than what's getting put in here. But, you know, are those underground vault fires that we're seeing potentially there? Could those happen in the underground systems that we're seeing, that, you know, SDG&E, or I should say the IOUs are installing? Are those kind of hazards? Thank you.
I can go. I saw John come off video, but come on video, but I can go ahead and go. So the vaults in San Francisco are a pretty different construction method, et cetera. The underground San Francisco, for example, is a network system where there's multiple loops of underground electric assets that kind of overlap and interact. And those vaults are where multiple circuits come together. They're like traffic intersections of an undergrounding system. That is not at all how we're building the underground systems in the rural areas, which tend to be linear and sort of radial, if you will. And so the underground boxes we are putting in the wildfire areas are very different. Nonetheless, there is always the potential for electric assets to fail. They almost always just result in an outage. But we have our ongoing inspection process for underground assets, whether they be in boxes or vaults or pad mount equipment, to make sure that they're in good working condition and that kind of thing. So we don't anticipate those kind of concerns with the underground system that we're installing now. And we haven't seen that with any of the underground systems that are more in the rural areas that do exist in some suburban areas and things of that nature. So that is not a failure mode that we anticipate being common with the new undergrounding in wildfire areas. And then to your first question about or comment about the drainage, that's definitely something we are thinking about and talking about robustly with our environmental team, including what kind of fill material do we use around the at-grade to allow water to permeate in the right ways, but not necessarily become a channel. So very much aware and thinking about how we do that effectively.
I would say that, you know, I made the distinction about looking at equipment that was pre the general orders. And my understanding is that the equipment that failed that has resulted in these kinds of explosions are predominantly pre-geo orders. most the equipment that and it also involves equipment that is near or uses oil for cooling, which it's sure, you can burn the jacket off of a cable, that'll happen, but in general, cable and electrical failure, except for the arc, is not going to result in an expulsion of like flammable equipment unless there is flammable equipment there to be, and so it's related to the age and more in the construction technique, well, rather the construction technique of the time. And so that's my understanding. That's why I'm an advocate for developing plans to evaluate equipment from before GEO 128, because we pretty much know the performance characteristics of equipment that's post GEO 128. Matt.
Yeah, I actually just wanted to cover one of my colleagues reminded me of something that yesterday, apparently the issue of seismic concern with undergrounding in wildfire areas came up. So I wanted to address that just real briefly, and then we could see if anybody has a question, wants to follow up. But we are working closely with our geotechnical team within PG&E to understand that, to think it through thoroughly. Of course, as we've mentioned here, we do already have a lot of undergrounding assets, undergrounded electric assets, as well as gas assets, which have some similar characteristics, and we've seen them perform through multiple earthquakes in different areas of our rural and urban areas and that kind of thing. We recently had some earthquakes in the Greenville Dixie Fire footprint area, which resulted in some land movement and also an opportunity to see how our recently constructed conduits and stuff performed, which was good, and they are flexible. They're not a super rigid whatever material that would crack or break in earthquakes. So it's something we continue to monitor and continue to think about in partnership with the geotechnical experts, but not something we see as a primary failure mode or high risk factor for underground electric assets, which we've already got tens of thousands of miles of that perform through various seismic activity.
Thanks very much for circling back on that issue. John, was there anything you wanted to add to that? John Meader from WSAB, anything further you want to add?
I'm good.
Okay. We have a raised hand. I can see one raised hand, which is Zoe Harold from the Green Power Institute. Zoe, did you have another question?
Yeah, thanks. Actually, that was my question from yesterday, the seismic overlap with the undergrounding. And so my one question is, what is the exposure overlap of, say, like the current undergrounding plan and risk of seismic disruption? Is there not a lot of overlap? Is that kind of what you're seeing, or?
Right. Yeah. All our analysis of historically installed underground assets, how they perform in earthquakes, and the current technology, what we're using, the tools, et cetera, we do not think there is significant risk to the underground electric assets of seismic activity. It's something we continue to monitor. We had one where there was a landslide, and so the land eroded away and exposed our underground asset, but the asset itself was fine, was plenty healthy. And so we don't see a significant overlap of risk there.
Thanks.
Okay, Katie from TERM, you have your hand up.
Yeah, sorry. Matt's comments just raised a question for me. He referred to a landslide where the assets were okay, but I kind of wanted to know a bit more about what's the process there for the asset itself is okay, but then do you have to re-underground? How do you what are the steps and how do you prevent that from happening again? Especially, we're seeing more landslides and mudslides because of these heavy rains. How do we make sure that underground lines stay underground?
Yeah. So that's an example where we would partner with our geotechnical department, who have both internal and contracted resources to help us come up with a plan. And do we think that the ongoing stability of that hillside most likely is robust enough that we can keep our asset there, or maybe slightly relocate it within the same hillside, or should we do something different? Should we take a very different path? A lot of our assets follow roadways for a number of reasons that make sense. But we also sometimes see washouts of roadways, right? And so if the roadway washes out, the utilities potentially underneath that roadway could be exposed. Or so the same kind of analysis that then the county or Caltrans would do to say, hey, is this still a good place to keep our road? Or how should we reinforce it? Retaining walls, things of that nature. So potential solutions could include a retaining wall to hold up the material that's going to keep our line underground, right? Another potential solution is to maybe do a bore or something through a different angle so that we create additional cover for our line without having to totally relocate. So it would be a case-by-case basis based on the analysis of the geotechnical team for what we need to do in that location.
But what I'm hearing is you're basically, I mean, I guess I'm not, for PG&E, I haven't reviewed the cost drivers of undergrounding, but you are having to revisit all of the trenching, potentially adding in more protective infrastructure. So all of those costs are just coming up again.
Yeah. So in the rare case when there is this kind of situation, right, which we know happens in California, but doesn't happen that much. Yes, we would need to do a reanalysis and decide what to do. I mentioned the fact that a lot of these are in roadways. So often the road authority is rebuilding or is doing something, right? And so we may be a part of that solution, which is the road authority, county or Caltrans, maybe putting in a retaining wall to support the roadway. And we can, gain support for our underground asset by staying in the road, which will now be supported by a retaining wall. So there could be costs associated with it. We don't see that very often. But yeah, that's how it would be handled.
Great, thanks very much, and thanks, Matt, for taking so many questions there. Okay, last call for questions before lunch.
We do have another question from Wendy Almukdab.
Wendy from the CPC, go ahead.
Thank you. Actually, it's more of a comment. So with the discussions about, possible alternatives that might be needed in certain situations for undergrounding, I just want to point out that the undergrounding conversion factor from overhead to undergrounding, PG&E right now is using about 1.25 conversion factor. That really impacts, if that conversion factor is higher, if you need to have more undergrounding for the same amount of, to replace the same amount of overhead lines and reduce that exposure, that really impacts not only the cost, but the risk reduction amount. So I just want to just point that out, that when we're talking about undergrounding, and especially comparing it to covered conductor or anything else, I mean, we need to be focused on how many lines of overhead lines that are being replaced. So just wanted to point that out.
Thanks, Wendy. Appreciate you pointing that out. Okay, last chance for questions.
Lucy, I think there's a technical expert, Jeff, who's got his hand raised.
Oh yeah, sorry, I can't seem to see any of the hands, right? So, Ring, would you mind unmuting Jeff?
Yeah, hi, can you hear me okay?
Yeah, we can hear you. Jeff, would you mind saying which organization you represent?
Yeah, I'm director of the PG&E Geosciences Department, and that's a group of geotechnical engineers, seismic geologists, and seismologists that support all the different business lines in the company. And I had a couple comments regarding seismic hazard and risk for the undergrounding. First off, underground lines are inherently stable and they are more resilient than overhead lines. So for example, in an earthquake, one of the main issues is having line sway. So the poles start moving, the line sway, and can connect with each other, causing a spark. Also, there are some weak links in that overhead system. It would be cross arms, different connections. Underground, you do avoid that. So the main seismic hazard for the underground lines, or if you have a type of ground failure, let's say soil liquefaction or landsliding. And there were some questions regarding that. We do have detailed maps and experience along our alignments. And so we first of all try to avoid areas of unstable ground. If we cannot do that, we do have some design options. One would be, and Matt mentioned some of these, is to extend the trench deeper. So let's say we're entering a landslide zone and the bottom of the landslides are 3 to 5 feet deep. We can deepen the trench so it goes below the landslide plane. Another approach is to have directional bore, so just loop under those zones. And another approach is to put connections on either side of a potential landslide zone. And so if you have movement, you can reconnect, have a box access on either side of that. But these lines are quite flexible, and so they can accommodate a fair amount of ground movement. So if you compare overhead versus underground, underground definitely performs better and is more reliable with regard to seismic issues. In general, landslides, we do have occurrences each year during heavy storms where we lose poles. And so overground is vulnerable to landslides, just as undergrounding in the same reach would also have an exposure. But when you compare them side by side, the undergrounding is more resilient.
That's great. Thanks so much for your comments and for coming online to share your feedback on that particular issue. Thanks, Jeffrey. Okay. Looks like, Rain, can you see any more raised hands?
At this time, there are no other raised hands.
Okay. I might draw the line there then and say that it's lunchtime. I know I'm certainly looking forward to my lunch. It's 11:59, so I say let's come back at 1 o'clock. And I'll put that in the chat.
Hi, all. Welcome back from lunch break. I think I'm just going to give it another minute or two for folks to trickle back in, and then we'll get restarted. All right, everyone, and we are back. So for our next topic area here, we're going to be hearing from Fred Cowell of GGI on asset replacement and repair frequency. Go ahead and take it away, Fred.
Thank you, Emily. Again, my name is Fred Cowell. I'm a Senior Technical Program Manager with Green Grid. I'm going to be discussing asset replacement and repair frequency. Next slide, please. So as my colleague, Dr. Maharami, touched on with her discussion of safety factors deal with a structure's ultimate strength. As a consideration of aging infrastructure, it is likely that a structure's strength decreases over time. When structures reach reduced safety factors, replacement is critical. As you can see, for A and B types of construction, or the most common types of construction, safety factors cannot fall below 2/3 of the standard before being considered for replacement. For grade C construction, the minimum safety factor must remain above half of required standards. This begs the question, are these minimum safety factors set at the correct level, or do they need to be reconsidered due to climate changes and aging infrastructure? Next slide, please. Now let's take a look at inspection requirements. Based upon the table on the right, pulled directly from GO 165, are these inspection timelines adequate to minimize wildfire risk, or do these need to be reconsidered given the dynamics of aging infrastructure? Can we incorporate differing inspection cycles for non-exempt equipment? As an example, could the inspection interval of rural overhead switches and protective devices be altered to include exempt equipment? With that, I'd like to turn it over to Mr. Chinmoy Saha.
Thank you, Fred. Next slide, please. Most of the inspection and replacement related questions that were asked and commented during the system hardening portion of this presentation, we can go much deeper into that because this is more appropriate, replacement and repair frequency. So what this is related to maintenance program. And we can see there are some observations that we have done. There are data that can be gleaned from various sources, and looks like public utility commissions, they have some data, and CAL FIRE shares that as well. I would like to draw attention to that chart on this slide from 2014 to 2021 for one IOU. If we see that ignition causing equipment that caused ignition, there are 254 in 2014, and 2021, it was 479. So the trend is upward. So that begs some question that what is that happening here? Why is like that? We have GO 165 that requires every IOU to have a maintenance plan. And if that maintenance plan is adequate, then there should not be an upward trend of asset failure, right? So I think our distinguished panelist during that asset hardening section mentioned that there is opportunity of innovation in maintenance program as well. I could not agree anymore. So if you see those, like what is happening? Do we know the life cycle of equipment that those are failing? Do we know what were those equipment, who were manufacturer? Were there any manufacturer's recommendation of maintenance, or we just fit them into what our GO 165 asks us to do? So those are the things I believe is a great opportunity for us to look at into maintenance program development and innovation. And what is the optimal replacement timing for each equipment? That is based on reliability, not based on time period. Whether it's soft time or hard time, it doesn't matter. We should look at the reliability of each equipment and see why they're failing. What is the dominant failure mode of those equipment? How do we address that? That will give us optimal inspection frequency if we want to discover the failure of an imminent failure or potential failure before it becomes a functional failure. So there is a term that is used mostly that is potential failure and functional failure timeline. If we can nail down those for every equipment through a developed maintenance program, then we can bring that curve in opposite direction, the inversion of the curve. Instead of the trend up, it will be trend down. So with that, let's look at into that. What is that innovation? What is the new maintenance program that we can introduce? Moving on to next slide. So this is the discussion point. That asset lifecycle based maintenance, that is reliability based maintenance, and that is nothing new. We are looking at other industry practices, RCM, Reliability Center Maintenance. That program was developed by United Airlines about 1970. Is consortium of aviation industry, including Boeing and major US airlines. They came together and they worked on this reliability center maintenance program instead of time cycle based or compliance based. And then they become successful. The DoD, they adopted it, I think it's early 1980. And then commercial nuclear industry, they adopted it 1990. And then recent is Disney, they have implemented into all their amusement park. So the result is significantly reduced incident and accident and improvement of cost. So it's very cost effective because you have the history of each and every failure, and you know the failure mode and effect of each and every equipment, and the dominant failure that can be taken care of through periodic inspection, on-condition monitoring, or continuous monitoring. So there will be some adoption in electric utilities industry because electric infrastructure is different than transportation infrastructure, but it can be adopted. If we can monitor the electric behavior through electric sensing devices and physical behavior before it becomes a functional failure through some kind of physical monitoring system, then your interval of inspection is zero because you're continuously monitoring your system. So that's the innovation that we really think that we should seriously think about it and see how we can adopt. It's not going to be an easy path, but if we can get to that maintenance program-based maintenance instead of maintenance program only, plan only, that is something going to reduce the wildfire risk significantly. That's what we believe. And with that, we'll go to the next slide. So Fred will introduce us that what is the current practice of inspection assets and what could happen in future. Fred, take it away.
Thank you, Chinmoy. Thank you. All right, so let's talk about inspection of assets. A little bit of background. Inspections play a critical role in maintaining the reliable operation of electrical infrastructure. To maintain a safety standard, ensure the safety of the public, and improve reliability, inspections must be frequent and rigorous enough to detect faults before they become an issue. Inadequate inspections are likely to induce risks into the power line system, while adequate inspections may identify risks, allowing them to be resolved, therefore mitigating wildfire risk. Next slide, please. Now let's take a look at our observations. We found that there is an opportunity for specificity in regulations, namely the frequency and rigor of inspections on both in-service and out-of-service lines. There may also be an opportunity for specificity in the corrective action timeline. Additionally, an opportunity exists to emphasize risk-based inspections over compliance/time-based inspections. There is also opportunity in the type of inspection methodology to include other new inspection techniques. Next slide, please. This brings us to our first discussion point: inspection frequency and corrective action timelines. A risk-based approach to inspection frequencies may be more resource efficient and yield more effective results and enhance safety while removing complexity, subjectivity, and regulatory compliance challenges. Next slide, please. Now on to our second discussion point: technology-enhanced inspections. We're all familiar with the current regime of inspection techniques: patrol, detailed, and intrusive. But what is the opportunity to include relatively new technology-enabled inspection techniques? Surely some of the newest remote sensing technologies, when incorporated with a data-driven approach, could help in the fight to reduce ignitions. Next slide. That concludes this portion of the presentation. I'd like to pass it on to Emily for panelist discussion.
Thank you, Fred, and thank you, Chinmoy, for your presentations and your thought-provoking discussion points. We'll hear next from our two panelists. We have Jennifer Kaminsky with SDG&E, and also we have with us Ray Fugere of SCE. Jennifer, would you like to go first?
Sure. So I've been working in the inspection space, starting with, in 2019, starting out a drone program for SDG&E. And that was kind of my step into the different inspection techniques that were just kind of touched on, these enhanced inspections. And I think, do you mind if I share just share a couple slides?
Not at all. I think to do that, thank you,
Brianna. Sorry.
No problem. Rain, perhaps you could help us set up that screen share.
All right, I think I'm able to do that now. Here we go. Just to help a visual, I think is always nice. Can you guys see my screen?
Yes, we can.
So you're seeing the basically asset management inspection programs, right?
Yes.
Okay, great. So here's just kind of a quick visual on, if you can see the traditional inspections that were just talked about as part of General Order 165 are these detailed overhead visual inspections. And obviously I'm targeting this conversation really regarding wildfire risk. We also do underground inspections, which I'm not really discussing on this slide. We also have patrols and intrusive pole inspections. And we've been doing additional inspections. I mentioned the drone program inspections that SDG&E started for distribution and transmission in 2019. But we also have early fault detection. We're investigating radio frequency, and early fault detection, radio frequency are some of that kind of continuous monitoring that was just mentioned. We're still in the experimental stage a lot with this, but looking into how this could help us identify potential for faults earlier in the process, infrared inspections, and then we have LiDAR inspections. I think one of the big takeaways for me in going through these inspections is, you know, the drone inspections alone have really helped decrease the poles that we've seen with issues over time, kind of going forward. And so we did see that we were able to find a lot more issues having that top-down perspective, being able to zoom in and get high resolution on some of our hardware. But what comes into play is now we have these detailed inspections happening and drone inspections. And so GO 165 has these, very structured compliance. We build systems. We have hundreds of thousands of poles. Our counterparts in California have millions of poles, especially on the distribution side. So managing those enhanced inspections and traditional inspections can cause multiple visits to the same poles, bigger impacts to customers that are having, us potentially going in backyards or out to the same area, some inefficiency. And so moving towards a risk-based inspection program is really where we're trying to push ourselves to. And we actually, as part of additional enhanced drone inspections, we did develop a new risk tool. So we developed a new risk prioritization model that allowed us to bring in data regarding consequence of failure, as well as the probability of failure. So thinking about what was just mentioned on aging infrastructure or what types of equipment, the failure ages that we have data for of when we see different types of equipment failures, different types of poles, even the types of wood, and where they're located within the service territory. Are they in the coastal areas, higher wind, higher elevation, and what the probability differences are amongst all of that infrastructure, and then trying to create a model that balances all of that data and gives us a high priority list of what infrastructure is important to visit in that next inspection cycle. So that helps reduce the number of times we're visiting brand new steel poles that have been fire hardened with the latest equipment, covered conductor, those kinds of things, or that are already planned for replacement or underground. We take that into consideration. The other thing that we brought into the tool is efficiency. We don't want to necessarily be looking at one pole over here, another pole over here. We want to make sure that when we send our inspectors out, we're able to get through a lot of infrastructure and make sure that their day is full and they are being efficient with their work, because that also translates to making sure that when we do repairs, we can make sure our crews are going out and being efficient with how they get those repairs done. So all of that is kind of taken into consideration within this model. This is the first year we're implementing it. We're going to be analyzing it to see how well we did, adjusting any of the inputs or the weights that we did for the different factors, and seeing what improvements we can do for next year. So with that, I will kick it over to my colleague Ray to see if he has anything, unless there's any questions.
Thank you, Jennifer. I think we'll go ahead and hear next from Ray, and then we'll open it up for public comment.
Thank you. So SCE is very similar to SDG&E, that we are using additional inspections above and beyond what is in General Order 165. So we have very similar, we're launching the EFD, we do drone inspections, we do infrared inspections, we're also doing corona inspections on our transmission system. So we believe that doing inspections above what's in GO 165 is a good thing to do, because you can learn more information, you can find things before they fail and create a public safety event. So we believe in that. Also, fundamentally, we believe in risk prioritizing our inspections as well. So at Southern California Edison right now, just to give a little background, we have been doing risk-based inspections in our high fire areas since 2020. We develop a process where every year we review all our assets in our high fire area, and we prioritize those for inspections. And we're using the two variables of risk. We're using consequence, how large of a fire could occur and how devastating could that fire be, and also probability of ignition. So when we talked earlier about, age, this is kind of how we incorporate age and other factors in that we learn from our lessons learned. So we have machine learning models that tell us the probability of a failure, and then we correlate that to probability of ignition for our structure. So we're using that information to drive our inspection cycle. So if an asset does have a higher probability of failure, we're catching it more frequently on an inspection. So having regulations that go to risk-based, fundamentally, I think we like the concept, but also with that, we can also look at risk-based the other way. There may be some assets in the non-wildfire area, because we also have to do overhead and underground inspections. Maybe those cycles are too short. So if we go to risk-based, want to not just focus only on the assets in wildfire, but really look at risk-based overall, because we should look at the whole system and, you know, be strategic on how we're applying that. So we agree with that. Now on repair maintenance, also we're starting to develop and really look at doing risk-based maintenance. So not just, you know, because currently the construct of the regulations is 6 or 12 months if you're in a high fire area. Obviously, there could be some conditions you want to do sooner based upon not just what you found, but everything on the pole, because it all adds up. So we're starting to look at that as well. So as we're looking at switching to risk-based, we're open to the discussions. We think they could add value to really focusing the energy and attention of the utilities on what is the riskiest asset and conditions, because that is ultimately what we all want to do, is focus our time and energy on the things that can create the biggest risks to the public. So in short, we've been doing this. We agree with looking at risk-based for inspections, and also really looking at doing risk-based for maintenance. Devil's in the details, obviously. Want to make sure we have flexibility to change, because one of the things we do at SCE is we have a fire scientist who looks mid-year at the conditions. What are the fuel level moistures in the conditions? And he identifies certain areas that the techno-silva model that we're using for consequence don't catch because of the dry vegetation, that it's drier than it historically is. So we're pivoting mid-year even and adding extra structures into our risk-based inspections mid-year. And we do this twice a year. So having that flexibility, not just having a very time constraint, you know, would be beneficial, because it would allow us to continue doing that. So I'll pause there and we'll open it up for discussions.
Thank you very much, Ray. All right, so yes, this is our public comment portion for this topic. If anyone has a question or a comment they would like to share, please do raise your hand, and we will call on folks in the order of hands raised. I see a couple hands. I think I saw Zoe Harold's hand go up first. So why don't we start with you, Zoe?
Thanks. So my first question is the drone inspections and some of the other kind of new technologies that are in use are above and beyond the GO 165 standards. And so I'm wondering what your thoughts are on whether those should be made into general order standards for inspection approaches, and if they should, you know, kind of go into requirements versus remain optional.
So I'll take a take for SCE. I like them being optional, especially, and the reason is because I like flexibility. And part of this is, as new technology comes out, maybe we don't have to have as many, you know, inspection based, you know, doing the drones or doing other things. As we get early fault detection, other inspection technologies, other sensors out, that could, you know, decrease the necessity for some of these other inspection technologies. Because if you get sensors on it and you're monitoring stuff more real time, you may not need to do those inspections. So putting them in regulations, you know, could hamstring us or make us have to do it even if they become obsolete, because changing regulations sometimes isn't the easiest. So I like having it being optional and, you know, letting the risk drivers and other factors drive those inspections.
I'll also echo what Ray said. I think that we see a lot of value in the aerial perspective, getting those high resolution images. But I'll tell you, even from when I started working on the drone program, what we were looking at, how could we even get images quicker and more efficiently from like helicopters, and the technology that existed in the cameras of the resolution you could get back in 2019 is significantly different than what I've seen recently. and really even able to look at the top of distribution poles to see if there's any, if it's hollowed out, to get in on the equipment. So as you see that technology, the methodology really needs to be agile. And so, you know, one of the things that I've thought about with GO 165 is if you allow the utility to develop a their own plan, risk-based plan that outlines what technology they want to use, what type of innovation and methods, it's a little bit more agile. And because we all know that changing a general order is a very long process. And so allowing a plan to be approved as something changes, new techniques come about, new methods, to me that gives that flexibility to change as we are seeing technologies change so rapidly in this industry.
And so is it correct to understand that basically a lot of these new inspection technologies are just really a rapidly emerging space that's, you know, constantly changing, and you guys are updating methods and how you actually apply them in your territories?
I'll say for SDG&E, that is the case, exactly. Even the types of drones we use, the types of cameras, the radio frequency and the early fault detection sensors are new and changing. The non-intrusive inspection sensors, you know, where they actually are using kind of electro currents to determine whether there's interstitial space, keeps evolving. And I mean, every year we're looking at new vendors and new products on the market. So just like you get a new phone, it seems like every year with new features, we're seeing it the same way in this space. And there's constantly new tools coming out.
Yeah, I agree. Things keep changing and changing very rapidly. And so the flexibility is really important, especially when we're starting to look at, because we're looking at, you know, meter 2.0, the advanced meter 2.0. The new meters have technology that will help us learn and be able to help sense stuff in real time. So we're trying to figure out how to build that in. So there's all these new technologies that keep changing faster and faster. I like the analogy of the phone because, you know, I still remember my first iPhone compared to what it does now. It is ridiculous on how fast it changed. And thinking about this, like we launched our drone program in 2019, and where we started and where we are now, it is severely, it keeps enhancing rapidly. You know, we're adding AI ML to this, so we're having the machines look for defects and getting, you know, using it as a quality check as a back end. So the technology, not just the hardware, but also the software on the back end is changing. So having that flexibility of how we incorporate things really is needed.
And then the second half of my question, and similarly around whether or not these general orders determining inspection cycles should be updated, is about the frequency of inspection rates. And so kind of, you know, what are your thoughts on whether, say, like HFTD inspection frequency for detailed or patrol inspection should be updated in the standards?
I'll take that first. So again, what I've seen in the HFTD, for example, there's been a lot of focus. I know SDG&E and the other utilities in California on our high fire threat district, tier 3, tier 2. We've done a lot of fire hardening, we're undergrounding, we're putting steel poles, there's different equipment standards in place. And so it begs me to ask the question, with that hardening that's going on and with the different infrastructure, it doesn't make sense to inspect at a higher frequency or, you know, just time-based, thinking just time-based on brand new infrastructure that we have different data in terms of longevity and failure rates versus wood poles or different types of equipment. So you really have to think about it, trying to move, it's really difficult, right? To move your brain to a space where it's not just thinking about, well, we have to do this every 2 years, or we have to do this every 3 years. It's thinking about each asset almost as a unique, you know, a unique facility. And what does that particular pole, what does that particular, and where does that pole exist? a pole that's on top of a mountain that has severe weather changes, right? It's like extreme cold, more rain, especially in, you know, San Diego, where SDG&E is very different than what we have in our desert environment. It's so different climates, or the coastal areas where you have contamination zones that are affected by salt water and being closer to the ocean. So I think about all the different factors and the unique variables that exist, and really thinking about our inspection program holistically.
Yeah, and I echo most of the same statements. It's instead of changing the cycles, if we can shift to more of a risk-based approach, which I think is what I kind of said earlier, not just for high fire, but also looking at developing a holistic risk approach for General Order 165, shifting away from just 1 to 5 that was established in 1998-97 timeframe, so 25 years ago, shifting to more risk-based, especially as we get more new technology out there where we have confidence, and as we harden the system. You know, we have now hardened over 50% of our distribution miles with covered conductors, so that risk profile has significantly changed. So having those regulations be able to adapt and look at other factors, I think, is really where we need to go with our inspections.
Great, thank you both.
All right, thank you very much, everyone, for the good discussion. I see we have another hand raised, so we're going to move on to our next question or comment. Andy, Ambridges and PG&E, would you like to go next?
Yes, thank you. I want to reinforce a lot of what Ray and Jennifer have said, but I want to add a little bit more nuance to some of the items. With regards to the inspections specifically, you've got to think of the inspections in a couple of different ways. One is where there's fire risk, you're looking at the assets in those areas from could those assets cause an ignition should they fail. So that's an important distinction, because when you look at it in the non-fire districts, you're looking at it, if that asset fails, will it cause a reliability issue or a public safety issue in terms of someone getting hurt just because that asset fails? Very, very different consequences. Now, you also look for reliability in the fire space as well, but that look in the fire space, in the HFTD space, is different, right? So that has to be brought into consideration as you look at the inspections we do. So that's like, there are very two distinct types of looks that you have to take. And the regulations currently don't accommodate that piece. And, you know, moving to that would be something that would be very helpful to for and recognizing the wildfire risk. The second aspect of this is when you think of the inspections, as was highlighted by Jennifer and Ray, the range of technologies that we're now expanding is also expanding on us, but we have to break it up into two components. How is the electrical infrastructure performing? Which means, are we noticing incipient defects? And that's really what's related to the EFD space. But those technologies are still in their, let's say, not as mature phase. And what I mean by that, while electrical fault detection, where it'll tell you that you've got a bird cage or something happening on the wire, it's not sophisticated enough just yet to tell you when that is going to result in a failure. And so as you deploy these rapidly, what you could say is, hey, every small defect comes in, but that defect is not going to fail. And so now you've got this challenge back and forth, which we've got to be very careful about deciding, because we want to address the areas that are going to fail in the near term and get ahead of those versus something that could fail in like 4 years, right? Even though it shows the defect is forming. So that sensitivity has to be brought in. That's why the flexibility in what was being brought up. But the third piece to bring in, it's very distinct. There's electrical type defects that you're looking at, and then there's structural type defects. And structural type defects, aerial inspections, inspections from the ground, pole test and treat, all of those give you a viewpoint of the structural defects, but they're very distinct. And right now, we've got to make sure that distinction is there in the new regulations or proposals to change in the regulations. That's what we'd ask for. but keep it flexible so that we can use the multitude of technologies coming on play to do this. All of that said, definitely from a risk-based approach, because the location has such a big play into the impact of the consequence that happens. So much so when we think about it at PG&E, right, when we dictate the inspection cycles that we'll do in high fire threat districts, we actually don't pay as much attention to the probability of ignition. And not because that's not important or that can't give you information, but if you're inspecting something, you're saying, I'm looking for a failure, I'm more concerned, I'm going to say is, if I don't know anything, is that thing going to fail? I would assume a probability of ignition of 1, because the consequence of that location is very, very important at that stage. So we use consequence very highly in our inspection cycle development for high fire threat districts. All of that is around the inspection side of the equation. If I move a little bit to the repair side, because this is inspection and then replacement repair, the repair frequencies that we got to think about very carefully is the inspections that as they detect level 1, and a level 1, right, I think the regulations are really, really good, and we should hone in on that and support that wholeheartedly. I don't suggest any changes in level 1, because when you find something that's imminent failure, you've got to respond to it. We keep standby, all of that, and it triggers that emergency place, because it could cause it could cause harm to the public, or it could cause a fire. So level 1, the flexibility is really needed on level 2. Level 2 needs to move to a risk-based, given the location, given the consequence that could happen, and given the estimated, which is the tough challenge, how long will that asset before that failure actually manifests itself? And you can be guided by actual data on actual failures that have happened on level 2 tags, right? You say, what's the data on that? And that could be the way that we could share with the commission and others, what exactly and how is it guiding the timeframes we're using for level 2 repairs, both in a high fire threat district and in non-high fire threat districts. You could use that same concept, because I'm in the same place with Ray, use it consistently across the board. The last element that I don't think was brought up anywhere was, you've heard Ray say, there's a rebuilding effort of the grid going on. We just had the undergrounding panel. We were talking about covered conductor. There's a lot of good work that has already been done. When on assets that have already been rebuilt, those inspection cycles need to be different. And I think we touched on that. But what we're not thinking about is we're going to be rebuilding this grid. So it would make no sense to inspect, write a repair tag, and then come in within a year and rebuild that section of the grid. But the current regulations require you to do that inspection and providing flexibility, provided you can say, here are the locations where we're going to rebuild, and a statement to the effect that if that section of the grid is going to get rebuilt within the next 12 months, there's flexibility in terms of doing a repair there or doing an inspection there. That I think would be balancing the cost equation as well and balancing the customer interaction. So I just want to put that in those three discussions for people to consider.
Thank you very much for your comments. Did anyone have a immediate response to that? Otherwise, you can move on to our next raised hand. All right. Oh, sorry, Jennifer, go ahead.
No, there's a lot of hands raised. We can move on to some of the questions. Thanks.
All right, sounds good. I did see a hand go up from Kevin Miller. Kevin, please go ahead and state your affiliation and your comment.
You're on mute, Kevin, if you're talking.
Kevin has put down his hand.
Oh, all right. No worries. Then we'll move on to our next. I see a raised hand here from Holly Werman of Cal Advocates. Please go ahead.
Hi, thank you. My name is Holly Warman. I'm a senior utilities engineer with the Public Advocate's Office at the CPUC. So I found this discussion very interesting and informative. One area that I have not heard much discussion about and I want to bring up is the areas of quality assurance and quality control of your asset inspections. While the general orders require a certain frequency of detailed and patrol asset inspections, they are fairly quiet on the subject of QA and QC, and I think that's a very important topic, particularly to consider if you have a lot of contractors performing inspections, as is the case with the large IOUs. It's important not only to be performing the inspections, but to know how that the inspections are being done to the utility standards and that they're finding that the issues they should be finding. And in our review of WNPs this year, we found pretty significant differences in how and where and when utilities implement quality control of their asset inspections. And so that's an area where I think we should, I guess my question / comment is, should we be considering rules in the general orders around appropriate quality assurance and quality control guidelines for asset inspections? And as part of this, I want to reiterate an important point is that the general orders generally set minimum acceptable standards. And so I appreciate the need for flexibility in how utilities operate, but I do want to point out that it is, I believe, necessary to have bounds set on minimum acceptable standards for various activities and have flexibility to go above and beyond that, but there should be bounds set for safety. So those are the 2 points I wanted to bring up. Thank you.
And so QA/QC, I am a proponent of QA/QC because our inspections are the eyes and the ears in essence of our system. So making sure that our inspectors are doing it and doing it correctly, we need to do it. And so we do have a robust QA/QC program. We even take a risk-based to our QA/QC program. So higher risk areas in our higher fire area are QA/QC to a higher frequency and level of confidence. So I think it's a 99.1 in our riskiest areas is what we're using, and it's a 95.3 in other areas. And we kind of gradient depending if it's high, medium, or low. So QA/QC fully believe, because we need to know that our inspectors are doing correctly. So now, does that need to be codified? I think that goes more into the utilities have an obligation to comply with the regulations. And our QA/QC programs are how we help determine if we're complying with that regulation. So I'm not sure I'm not sure that needs to be in there. It's our duty to make sure our inspectors are doing it, and we use our QA/QC program to ensure that. So that's kind of the one point. Your other point about the bounds, I do understand, conceptually, I get the concept. Put some at high end or whatever the external bounds are, whatever that cycle is. I think it all is the devil in the details of how it gets, codified. I'm not saying yes, not saying no. I understand the reason for some people liking to have that. I still like pure risk-based, but it's an interesting point. I understand that point, and I think it'd be in the future as we look at this, it'd be something definitely to consider and discuss in a more robust setting.
Yeah, if I could provide a perspective on that. QA/QC, as Ray indicated, we've got qualified electrical workers going out and doing that work. And they're doing effectively visual inspections, which are notorious. Visual inspections in other industries, by the way, have been proven to be ineffective, right? I've been in the manufacturing industry on medical devices. I've been in the manufacturing industry and the design industry on space devices. Satellites specifically. In our space, we use qualified electrical workers And as they do that work, right, you've got to make sure they're trained, and the QA/QC has a role when they're looking and using visual techniques to identify defects. So that's definitely a hazard space. But QA/QC programs should be intended to find where flaws are happening in either training, in the processes, to provide the feedback so that you can bolster that up and make the changes, because you want to find it. You want to find the defect before the defect finds you. And fundamentally, what the regulations should look at would be is, are you finding defects where you are seeing failures, or are you seeing failures and you didn't find the defect? That would be a much more useful space for the regulation versus playing in the QA/QC. Because as Ray indicated on the QA/QC space, we're actually automatically incented to get it right because we don't want the failure to happen, and the regulation should follow. How do you prevent the failure happening? Are you seeing failures on areas that you inspected and you saw the failure, but you didn't have a tag? That would be an example of that. That is where focus is unfortunately not happening. And that's where the regulation should focus on. That's my perspective, Holly, relatively a question. I know it was on QA/QC, but I hope I gave you the perspective on where the focus from a regulations perspective should be.
So I'll comment also regarding quality assurance, quality control. Definitely, same as Ray. I think everybody is a big fan of quality control. We do that in a number of different ways, and I think from when you think about a regulatory program, just making sure that things aren't too prescriptive, that again don't allow us to use different tools. So I'll tell you that for our inspections that occur, the only contractors, we'd use contractors, sorry, for our drone inspections. They are qualified electrical workers, they're linemen, but for quality control, we actually have multiple levels of quality control, including because we're taking photos with the drones and they're reviewed. So we have a supervisor that reviews the photos before the report is finalized. And we've actually started incorporating our intelligent image processing. So similar to Ray mentioned, we have developed machine learning models that allow us to detect damage identified from an image. We have 100% of the images that are taken by our drone pilots and reviewed by our inspectors go through those machine learning models and identify any discrepancies between what the image recognition model detects and what our linemen have found in the field. Those are then surfaced to the lineman and the supervisor in order to determine whether or not a condition needs to be added to the report, whether the model did a good job, not a good job. It helps continue to train those models and improve the artificial intelligence in that space, and allows us to have 100% of all the photos QA/QC'd. So when I say there needs to be flexibility in the rule regarding if we put a quality control rule in place, I think, just saying you have to have a program, but allowing, again, innovation to occur when we talk about quality control. We also obviously have audits of our programs, of our records, as well as field inspections that occur, and supervisors go out and look at a percentage of the inspections that were performed, as well as the repairs that were performed by crews, to again get another pair of eyes. But I think as we see imagery coming in and more easily available, like if you think about 20 years ago, it was not as easy to just take a picture of something. We have that technology now, and we want to make sure that we can continue to use it to help us with things like quality control. In terms of minimums that you mentioned, Holly, when we think about minimums, I agree there should be minimums. We want that to be included in a risk-based plan, but we just want to make sure that we're being creative about what those minimums and not just putting a time stamp on it. Right now, GO 165 just has a minimum in terms of time, not necessarily talking about risk. So we need, as I agree with Ray, we need to have a more robust discussion about what does a minimum look like in a risk-based approach rather than just time frame. And then one more comment I'll make is just the other thing that's really important as a utility, right, is record keeping. And the systems that we use are complex and robust. So we do need to make sure that as we think about these innovations, that we are cognizant of what the investment has to be sometimes in the systems that help us keep those records in place, that make sure we have good information going to the field in terms of what orders need to happen, what work orders, and we can keep that all in good record keeping, right? So that we know what we're issuing out to linemen, what they've completed. And if sometimes I've noticed that I'll think something's a great idea, hey, let's use this, but how do we integrate that into a system like SAP? It can be done, but it does take time and thoughtfulness to make sure that we don't lose sight of something as we make change. So just something to kind of put out there.
Thank you for those remarks. I think that is really helpful to expand on. All right, in the interest of time, I think we have time for one more question. I see a hand raised from Zoe Harold, Green Power Institute. Zoe, did you have another question or comment?
I do have another question. Okay, so bear with me on this one. I am not a grid operation expert, but my question is at essentially the nexus of increasing load across the distribution grid and increasing extreme weather events. So we've seen heat waves that are 1 in 35-year heat wave events, and how those asset stresses are being essentially incorporated into not necessarily a visual inspection, but an assessment of how the grid is being operated relative to aging infrastructure and the stress that operation mode might put on places that are at high wildfire risk. And how that's kind of being incorporated into an asset replacement and preemptive asset replacement to avoid run to failure mode.
So if you don't mind, I'll take that to start off. So it is something, so what you mentioned in terms of increasing load, we term electrification, right? We're seeing an electrification that's necessary. If everybody went out in the state of California and bought an electric car right now and needed to charge it, we would not be in a great place, right? And so we need to make sure that that investment in electrification and is happening across the grid, also responsive to climate change, as well as climate equity or energy equity, rather. We're looking at all of those elements that don't seem to be directly related to inspections, but have to be thought about when we think about these inspection programs. And I'll say for SDG&E, one of the things that we're really bringing up is, all right, well, what inspections do is it's very responsive. So we're going out there and we inspect something, we see something needs to be repaired, and we go repair that one facility. What we want to think about, and I think what was kind of leading to some of the conversation on Rule 18 in terms of the timeframes for repair is, and what I mentioned with even our model of how we did inspections, and I know Andrew brought this up, is we want to make sure that we're not just repairing one thing and then going back and upgrading it as part of a larger circuit effort. So we want to think about inspections to find those repairs, but also have the ability to look at it as a whole and say, okay, I've identified maybe 10 items on this circuit or circuit segment that need to be repaired. But how is this circuit or circuit segment potentially impacted by electrification or climate change or equity? And what could we do maybe as a company to really enhance that from a reliability standpoint or improve load delivery and do a larger project in that area that fixes those responsive items that we found, so we don't have faults or any sort of failure, but also helps to get that next improvement and we're being cost effective about it. So it's all actually very much tied together, and it's tied to, we keep going back to that agility in the regulation, but it's really important that we can look at those things and make smart decisions, timeframes, instead of just being like, well, it's due January 3rd. We have to do this January 3rd. Well, if we can get a whole project done by March 3rd, isn't that better? So depending on the severity of the issue identified, what the risk really poses to reliability and to safety. So with that, I'll kick it over to anybody else.
Yeah, Zoe, you brought up a really, really good point. Okay, and the point is, as extreme weather events take place, right, the stress on the grid is radically different. We're entering, I mean, the next few days is going to be a heat cycle, right? We can see that predicted. And I think what it leads us, and what the regulation should push us towards, right, is how quickly can you deploy real-time monitoring and allow the real-time monitoring to start to replace the visual inspections that you're doing. Because the visual inspections, if you're doing that for structures don't fail in the same way that, with stresses on the grid happening, you'd get like the electric capacity or a transformer failure, things like that, right? So real-time monitoring, pushing that and making that part of the inspection process would be actually very, very beneficial, incorporating that in a good way. But that's already being done to some degree. I think utilities are starting to go down that. Ray mentioned that, we're now getting technology in the smart meters that allow us to triangulate and detect locations that have a signature fault pattern. And I think that's up. The EFD we talked about is another way to do it. What we are currently doing in high fire threat districts, we think of our partial voltage detection on the smart meters. When we see 2 or 3 smart meters in a location that have a partial voltage, if the risk is really high, we force out and then we go inspect. And if the risk is not as high, we send a troubleman to go take a look at that to catch that issue. And you can see that happening on high heat temperature days as well. But then with all the machine learning and AI technology coming online, right, utilizing the load profile data that we have, really studying it and applying that through more advanced analytical techniques is something we're already doing right now with our transformers to make sure that we can spot transformer failures before they happen in advance of potential heat events, and then simulate heat events on particular circuits in the pattern to decide, right, if there's something that could be watched more closely or changed proactively. But your point is right on the money.
Yeah, I just want to echo kind of both what Andy and Jennifer said. They really hit that point. And the one thing Jennifer said that I think kind of goes back to where we started is about risk-based maintenance. If there's a condition that has that due date of, say, January 3rd, but we're going to be rebuilding that by March 3rd, if we need to have that flexibility to be able to bundle that into that other work, because it's sometimes hard to move like a whole large construction project up. But if we can extend that due date or something else, if re-examine or recertify that it's okay to last that time, that flexibility would help immensely with the utilities, because bundling work will help for cost pressures, but also will help for customer impacts, because the customer doesn't want to see you in January doing something, then 2 months later doing something else. So when we're thinking about this, having that flexibility to extend times or bundle it with larger scale projects is something that would really be beneficial. I just want to recircle back to kind of where we started and build off of what Jennifer said. That is really helpful to the utilities, having that flexibility.
All right, everyone. Thank you so much for the good discussion.
Sorry, this is Tyson from SDG. I just briefly wanted to respond to just on one more topic that I don't think was covered. And that's just that as we operate the system, regardless of the demands of heat and the demands of electrification, we don't overload the capacity of the conductors and cables at any time. So you talk about kind of the stress. They're all rated to a certain steady state value, and that changes depending on the size and types of the conductors. But if we run into a situation where we start approaching overloads, which rarely happens because we have a fantastic planning process that plans out these 5 and 10 year peaks that we see, We do look for other alternatives such as temporary cutovers, ways to move load around to avoid overload. So when you talk about like, hey, how is, are you expecting additional stress to lead to a shortened life of equipment or things like that? And again, we don't, I would say from an operations standpoint, we do not exceed the ratings of equipment.
Thank you, Tyson. All right. I think next we're going to go ahead and move on to our 10-minute break, but not to worry if you have additional questions or comments. There is going to be an opportunity a little bit later today for questions or comments on any topic covered during this 2-day workshop. Don't worry if something comes to mind, just jot it down. We'll circle back to you then. We're going to go ahead and take our break here. I think we'll be back at 2:10. And Lucy Morgans from Energy Safety will be facilitating the remainder of today's workshop. All right, everyone, thank you very much. And we'll be back soon.
Okay, I think the 10-minute break is now over. Thanks very much for Emily for facilitating the last session. So we now move on to the final topics of the day. They're going to be covered by Fred Carl from Green Grid, who's going to talk about additional safety considerations and other industry practices, and then moving on to Amy Chang, who's going to talk about regulatory change impact analysis. So Fred, over to you.
Thank you, Lucy. All right, I'm back. Again, I'm Fred Call with Green Grid. I'm going to talk about additional safety considerations. So while we've been dealing with all the current relevant regulations from within the utility sector, now we're going to take a look at opportunities from other industry regulations, such as the aviation industry. Why are we doing this, you ask? Because there are many opportunities to incorporate safety critical industry practices into existing regulations. That brings me to CAS, or Continuing Analysis and Surveillance Systems. So what is CAS? Well, it's practiced in the aviation industry since 1964. It follows the Federal Aviation Administration Safety Framework. CAS is an aviation industry tool used to monitor system health. It's a systematic approach to monitor and analyze data on equipment and performance and environmental conditions. It is designed to identify potential safety hazards and improve the performance of equipment. CAS employs data analysis, trending and statistical methods to identify abnormal patterns in equipment performance or environmental conditions. How can electric utilities employ CAS to prevent wildfires? Well, firstly, identifying potential hazards. Electric utilities can employ CAS to identify potential hazards associated with their infrastructure. This includes identifying equipment that may be at risk of failure, such as transformers, power lines, and other electrical components. By analyzing data on equipment performance, utilities can identify patterns that may indicate potential failures. For example, a sudden increase in the temperature of a transformer may indicate a potential issue that needs to be addressed. Next is environmental monitoring. CAS can be used to monitor environmental conditions that may increase the risk of wildfires. This includes monitoring weather conditions such as temperature, humidity, and wind speed. By analyzing trends in these conditions, utilities can identify potential hazards or potential risks associated with high winds or dry weather conditions. Next is an early warning system. CAS can be used to develop an early warning system for potential wildfires. By analyzing data on equipment performance and environmental conditions, utilities can identify potential hazards and issue warnings to personnel and customers. This can include notifying customers of potential power outages or shutting down power in high-risk areas, as we see with public safety power shutoffs. Next is proactive maintenance. CAS can also be used to implement proactive maintenance strategies to prevent equipment failure. By analyzing trends in equipment performance, utilities can identify components that may be at risk of failure and proactively replace or repair them before they become a hazard. Next, I'm going to talk about statistical analysis for scheduled maintenance optimization, or SASMO for short. So what is SASMO? SASMO is a statistical analysis tool that utilizes historical data to optimize maintenance schedules for equipment. It employs statistical methods such as regression analysis and failure rate modeling to predict when equipment is likely to fail. SASMO uses this information to schedule maintenance activities to prevent failures before they occur, reducing the risk of equipment failure and the subsequent ignition of wildfires. So how does the utility use SASMO to prevent wildfires? Well, firstly, through data collection. Electric utilities can employ SASMO by collecting data on equipment failures and maintenance activities. This includes collecting data on equipment performance, environmental conditions, and maintenance schedules. This data can be used to build statistical models that predict when equipment is likely to fail. Next, failure rate modeling. SASMO employs failure rate modeling to predict when equipment is likely to fail. By analyzing data on equipment failures, SASMO can identify trends and patterns that indicate potential issues. For example, if a transformer fails after 10 years of use, SASMO can predict when other transformers of the same age are likely to fail and schedule maintenance activities accordingly. Next, through maintenance optimization. SASMO can be used to optimize maintenance schedules for equipment. By analyzing data on equipment performance and failure rates, SASMO can identify when maintenance activities should be performed to prevent equipment failure. This includes scheduling maintenance activities for equipment that is likely to fail and reducing maintenance activities for equipment that has a lower risk of failure. And finally, proactive measures. SASMO can be used to implement proactive measures to prevent equipment failure and subsequent wildfire ignitions. This includes replacing equipment that is at a higher risk of failure and upgrading equipment to prevent failures from occurring. Next is our observations. So we do see some opportunity for specificity in regulatory requirements by transitioning maintenance programs from time compliance-based to risk prioritized condition-based programs, and possibly by adopting aviation-inspired practices. This brings us to our discussion point, electron worthiness. So what is electron worthiness? It's a framework designed to maximizes safety and minimizes wildfire risk for electric utilities. It's replicated from FAA airworthiness systems, proven for safety critical practices in operations and maintenance, and adopting to the design, construction, maintenance, and operations of electric utility equipment and support structures. It's a framework designed to maximize safety and minimize wildfire risk. Using a variety of methods from other industries, electron worthiness treats utility electrical systems much like the aviation industry treats an aircraft. Given certain go, no-go criteria, a utility circuit should not be energized until all go criteria are met, much like an aircraft is not deemed airworthy until all applicable safety requirements are met. Within this framework, special attention must be paid to the assets that form a utility circuit. Using the CAS and SASMO tools previously described, attention must be paid to the type and age of an asset in order to predict its longevity within the system and prevent a catastrophic failure that may ignite a wildfire. Due to the risks associated with aging infrastructure, inspection and replacement of aging components is critical. So we have introduced all of these concepts along with electron worthiness in order to promote a collaborative approach to grid optimization that will reduce wildfire risks and make California a safer place for all of us. That concludes my portion of the presentation, and I will turn it over to Amy Chang.
Hi everyone. Many of you have not yet met me. My name is Amy Jiang. My area of specialty is change and transformation, and today I'll be speaking with you all on regulatory change impacts. So to begin with, I want to set the stage by talking about the impact of wildfires caused by electrical utility lines. Later on, I will then use a few examples on changes we've discussed in the last couple of days to also help us understand the impact of the implementation of these regulatory changes. So the goal is to understand that while there are obvious social, environmental, and financial costs associated with these wildfires, there are also factors associated with the implementation that we need to consider. So let's start with this slide, which is when considering the impact of wildfires in California, let's start with the obvious consequences of wildfires. These can be measured in metrics to help us understand the scale and the severity of their effects. With each category of impacts, I'm going to mention some key metrics to help us understand the impact. So first of all, earned area. This is usually measured in acres. This is the total land area affected by wildfires, which provides a measure of the extent of the environmental impact. The metric quantifies the size of the area, the size of the affected ecosystem and the scale of habitat loss. Secondly, carbon emissions, as measured in metric tons of CO2. Wildfires release vast amounts of carbon dioxide into the atmosphere. Tracking carbon emissions from wildfires helps assess their contribution to greenhouse gas concentrations and climate change. Thirdly, air quality index, as measured in metric tons of AQI. Wildfires emit smoke and pollutants, leading to degraded air quality. AQI measures the level of harmful pollutants such as particulate matter and ozone, impacting human health and ecosystem vitality. There's also economic losses as measured in dollars. This helps us understand the economic impact of wildfires and helps us understand the consequences, the financial consequences for individuals, communities, and the state as a whole. This also includes the costs associated with firefighting efforts, property damage, loss of agricultural production, and tourism revenue. I want to mention that while that there's other losses, such as the loss of biodiversity, soil erosion, water quality, and impact on endangered species. These ones on the page are the most immediately measurable. So let's go into the next slide. Let's also talk about social impacts. Wildfires in California have significant social impacts that extend beyond the immediate environmental consequences. Here are some key social impacts of wildfires. First, let's talk about displacement and evacuation. Wildfires often lead to mandatory evacuations, displacing residents from their homes and communities. Displaced individuals and families may experience emotional distress, uncertainty, and disruptions to their daily lives. There's also loss of lives and injuries. Tragically, wildfires can result in the loss of human lives and cause injuries to firefighters, residents, and emergency responders. These incidents have a profound impact on affected individuals, families, and communities. Health effects. Wildfire smoke can have severe health implications, especially for those with respiratory conditions. Poor air quality due to wildfires can cause respiratory problems, exacerbate asthma and allergies, and increase the risk of cardiovascular issues. But while we're here, let's also talk about mental health. Wildfires and their aftermath can also lead to significant psychological distress among individuals and communities. Evacuation, loss of homes or possessions, fear, and uncertainty contribute to anxiety, depression, PTSD, and other mental health challenges. Community disruption. Wildfires disrupt the social fabric of communities, causing temporary or permanent closures of schools, businesses, and public services. The displacement of residents can lead to a sense of loss, social isolation, and challenges in rebuilding community cohesion. There's also equity and social vulnerability. Wildfires often affect vulnerable populations disproportionately. Low-income communities, marginalized groups, and those without adequate insurance coverage may face greater challenges in recovering from wildfires and rebuilding their lives. Emergency response and resources. Wildfires require significant emergency response efforts, stretching from resources of local authorities, fire departments, and other emergency services. The strain on resources can impact the resource to other emergencies and essential community services. So other impacts that are notable but aren't directly mentioned are, for instance, long-term social changes. For instance, repeated exposure to wildfires can lead to housing patterns that are changed and new relocation decisions. Okay, let's go to the next slide. So let's also talk about economic impacts. There's property damage and loss. Wildfires can cause extensive damage to residential and commercial properties, resulting in significant economic losses. The destruction of homes, businesses, and infrastructure leads to the loss of property value and requires costly repairs and reconstruction efforts. Disruption to businesses. Wildfires can disrupt business operations, leading to temporary or permanent closures. Small businesses in particular can suffer substantial financial losses due to reduced customer demand, evacuation orders, and damaged infrastructure. The tourism industry may also experience a decline in visitors, impacting hotels, restaurants, and recreational activities. The photo you see on the right, the green garbage bin, is an example of how a small local business was affected by an evacuation. As you can see, this is thousands of dollars worth of food being thrown out because there were no tourists coming through the South Lake Tahoe area during the Caldor fire. So let's go on to agricultural losses. California is a major agricultural state, and wildfires can devastate crops, orchards, vineyards, and livestock. The destruction of farmland and agricultural infrastructure affects farmers, ranchers, and related industries, leading to decreased agricultural production, lost income, and increased food prices. There's also insurance costs. The frequency and severity of wildfires in California have increased insurance costs to homeowners, businesses, and local governments. Insurance companies often raise premiums or refuse coverage in high-risk areas, making it more difficult and expensive for property owners to protect themselves against future wildfire damage. Currently, we're aware that there are a few major insurance companies that are no longer writing insurance home policies in the state of California due to the wildfires. Emergency response and resources. Wildfires require significant emergency response efforts stretching the resources of local authorities, fire departments, and other emergency services. The strain on resources can impact the response to other emergencies and essential community services. So, as we examine the social, environmental, and financial costs of these wildfires, it's also important to discuss the cost of implementation on the changes. So let's go to the next slide. We've heard across the past couple of days. So we are going to talk about a few examples just to explore this vein. This is not comprehensive. So let's just begin with vegetation management. Cost and resources. Vegetation management requires significant resources, including funding, manpower, and equipment. Implementing large-scale vegetation management programs can be financially demanding, especially for smaller communities or regions with limited budgets. Sustaining ongoing management efforts and securing long-term funding can pose challenges. Stakeholder concerns and opposition. Vegetation management practices can face opposition from various stakeholders, such as local residents, private landowners, and timber companies. Addressing stakeholder concerns is crucial for successful implementation. Scheduling and timing challenges. Implementing vegetation management practices require careful planning and coordination. Factors such as weather conditions, seasonal restrictions, and wildlife nesting periods may be taken into account to ensure the effectiveness and minimize unintended consequences. Limited windows for implementing certain practices can add complexity and reduce flexibility. And lastly, regulatory and legal considerations. So vegetation management may be subject to regulations and permits, particularly in protected areas or sensitive ecosystems. Compliance with environmental laws, ensuring appropriate permits, and addressing potential legal challenges can create additional hurdles and delays in implementing management practices. Okay, let's go to the next slide. So let's talk about undergrounding and some costs associated with implementation. We know that undergrounding can be very expensive. Undergrounding power lines is much more expensive than overhead lines. The cost of trenching, cable installation, and other associated infrastructure can be substantial, particularly in areas with challenging terrain or dense urban environments. The financial burden of undergrounding projects can be a limiting factor for widespread implementation, especially in settings with smaller budgets. Maintenance and repair challenges. Underground power lines are typically more challenging and costly to maintain and repair compared to overhead lines. In the event of fault or damage, locating and assessing the undergrounding cables can be time-consuming and complex. This can lead to longer service disruption and higher repair costs. Longer project timelines. Undergrounding power lines often involves significant construction work, including excavation and trenching. This can lead to longer project timelines, causing disruptions and inconvenience to communities during the construction phase. The coordination with multiple stakeholders, including utility companies, local authorities, and residents, is necessary, further extending project timelines. Lastly, environmental impact. While undergrounding power lines can reduce the risk of wildfires caused by electrical infrastructure, it has its own environmental impacts. Excavation and trenching can disrupt natural habitats, impact soil quality, and require the removal of trees or vegetation. Additionally, the manufacturing of disposal of underground cables and associated equipment can have ecological consequences. Let's go on to the next slide. The inspection of power lines, as another example, is an important approach to wildfire mitigation, especially focusing on identifying and addressing potential hazards or vulnerabilities in our electrical infrastructure. So let's talk about frequency and timing. Depending on the appropriate frequency and timing of inspections is crucial. Conducting inspections too infrequently may increase the risk of undetected hazards, while overly frequent inspections may strain resources and lead to inefficiencies. Striking a balance between inspection frequency and resource utilization is essential. Weather dependency. Inspections may be affected by adverse weather conditions. High winds, heavy rainfall, or extreme temperatures can impact the safety and feasibility of inspections. Weather-related limitations can result in delays, rescheduling, or reduced effectiveness of the inspection process. Third, cost and resources. Conducting regular inspections requires financial resources, skilled personnel, and appropriate equipment. Allocating adequate funding and staffing for inspection programs can be a significant challenge, particularly for areas with smaller budgets. Prioritizing inspections based on risk assessment can help optimize resource allocation. So in conclusion, there are costs associated with the changes that we should be made aware of, along with the cost of the wildfires itself. And it's important to take these all and weigh them appropriately so we're able to make the best decisions when it comes to thinking through the best methods of minimizing wildfires. Thank you.
Thanks very much for your presentation, Amy and Fred. So we'll now move on to the panel presentation. And I think first up is PG&E. And I think it's either Andy or Vince or both of you.
Yes, good afternoon. Can you hear me?
Yeah, we can hear you, Vince.
Thank you. So this is my first time on, so let me introduce myself. My name is Vince Tangay. I'm PG&E's Senior Director of Electric Appliance. While I've got the floor here, and this is the first time I'm on, let me thank Energy Safety for hosting this workshop, and we would certainly very much appreciate the opportunity to participate. We originally identified me as a panelist for this section. Since then, we've decided that we would probably be all better served if I cede my time to our subject matter experts who we've heard from before, Andy Branches, Matt Pender, and Jim Gill. So with that, I'm going to turn it over to Andy.
Hey, thanks, Vince. I'll provide the bulk of the comments for PG&E. On the regulatory impacts, I think Amy Chang did cover a pretty comprehensive list of regulatory impacts. And as she was reading through that litany, my thought process, we had reviewed it before. My thought process is fairly simple on this one. There's no easy solution. You're balancing wildfire risk with regards to a whole host of other concerns. And our goal is to prevent catastrophic wildfires for the very reasons that Amy outlined. But as you do those mitigations, you've got to balance that the mitigation with a host of other concerns, the concerns of customer interaction, customer disruption, the host of environmental, making sure you do it in an environmentally sound way. And then lastly, you do it in the most affordable manner for the long term. And so the way I think about it from the regulatory impact, right? And you've heard it repeatedly from comments from Ray Fugere and others from SDG&E, Michael Dalio providing that perspective from the VED side on SDG&E side. Our viewpoint on that is as we think through and changing the regulation, there are some instances that it makes clear sense, because if you provide more flexibility, right, into, for example, the level 2 tags that we talked about, the level 2 type thing, more flexibility in that repair cycle, it allows you to incorporate and prevent disruptions. It allows bundling, it allows cost effectiveness, and it allows it serves the purpose of achieving long-term resilience. But if you're too prescriptive in some area, what it could happen is it reduces flexibility, which then traps us into a regulatory regime that may get outdated as new technology comes into play. So that's the bulk of the comments I have. Happy to take questions as other panelists and members of the public join in on this one.
Thanks very much, Andy. We'll move over to hearing from Tyson from SDG&E.
All right, thank you. So good afternoon, everyone. My name is Tyson Swedick. I'm the Director of Electric Distribution Operations for SDG&E, and just excited to be a part of the conference. I've heard just kind of wanted to emphasize some of the themes that we've already heard today. One of the main themes is that we heard from many different participants in the workshop, is that, the different utilities have diverse service territories, diverse from each other and diverse within our own service territories. And that there's just this value in having flexibility to apply the right mitigation and priority to the specific assets with the specific asset attributes with their, specific local conditions. And so, we're SDG&E, we're very open and supportive to this effort, but really do kind of appreciate this area where we're looking at like what are the potential, impacts of regulation and kind of this emphasis that we need to be really thoughtful and balanced in how we approach making changes to the regulations so that we're achieving our goals of minimizing the risk of wildfire, but also keeping kind of all stakeholders in mind and ensuring that it's affordable, ensuring it's efficient as we go forward. Now I'll just kind of get into some of the discussion points. We talked about vegetation management. I know Mike DeLeo went into that a lot for SDG&E the other day, but just a couple kind of high level points. If we were to make like a prescriptive regulatory change, maybe, in some of our WMPs, we're performing enhanced vegetation management, we're obtaining greater post-trim clearances. Say we turn that from, a goal that we had into a regulatory requirement, we're all going to achieve 15-foot post clearance. It's interesting to start thinking about what are the impacts if we make that, from the goal to a regulatory requirement. On the positive side, I think when we work with customers and things like that, it's a much more powerful and persuasive argument to say this is the regulation and the law. This is something we are required and we need to do. So there's kind of power there in achieving the goal versus saying, hey, this is a best practice and a standard to improve safety, but we really don't have the regulatory backing to do so. And then, I think another benefit is, we believe in enhanced clearances, and we think by achieving those, you're going to have a more effective program. You're going to have less vegetation contacts. But again, kind of on the potential negative side of creating regulation like that, and under the current circumstances, we have again some flexibility. We have a certified arborist that has knowledge of the specific species, and perhaps to get the 15-foot requirement, they would have to trim so much that it would essentially kill the tree. It's no longer a tree trim, it becomes a tree removal. Where under the current setup, we could look at it and say like, okay, let's get 12 feet. We can substantially reduce the risk. We know the species. We think we can achieve the goal, the purpose, the intent of the program, which is to reduce the wildfire risk, while keeping our customer and our stakeholder in mind and allowing them to trim the tree and keep the tree that they love to have on their property. Right. So when you add regulation that's firm like that, you do lose the nuance to be able to do things like that. Again, that flexibility to do what potentially might be the right thing in that circumstance. And then I think it was mentioned on the slide, but if there's anything that for any utility where we make a recommendation or a requirement that is beyond the scope of what we are doing today, there can be significant cost increases associated with moving from that previous level to the new level of requirement, in a certain time frame, and potentially could even be feasibility issues around hiring enough personnel to ramp up in a time frame that's desired by the regulation. So just kind of some specific examples there. I also wanted to touch on just inspections. I think that's a really good one that I think there's a lot of opportunity on. I think Ray mentioned, some of the GO 165 regulations have been around for a very long time unchanged. I know, Jen talked about some of our risk-based inspections and just the value in that. Essentially, can we be efficient with our resources? Do we need to perform detailed inspections every 5 years on brand new assets when we could be performing maybe inspections every 2 to 3 years on our highest risk assets that are in potentially worse condition and potentially in worse impact areas? So it's really kind of all about that efficiency. And I think today, we're still performing our 5-year detailed inspections. We're performing our patrols. We're meeting those minimum requirements. And then on top of that, we're performing these enhanced inspections to help support, reducing wildfire. I know we would love to see some mixing of those programs to where some of the enhanced inspections could count as the detailed inspections or count as the patrols, or essentially achieve efficiency and some cost savings there by essentially mixing some of the enhanced programs with the GO 165 kind of requirements around what's a detailed inspection and what's a patrol. I did want to touch on a comment that was made on do there need to be certain minimum levels. I do agree with that concept. I think it'll be a good discussion on what that looks like with all the participants. What is that? I still think, for example, patrols, even on new infrastructure, I still think it's good to go see your infrastructure at least once a year. Make sure it hasn't been hit by a vehicle. Make sure it's still safe. There's still, I think, certain minimum levels that, for the safety of the public, regardless of wildfire, just makes sense to check. But I think there's certainly opportunities to be more efficient and to really spend our resources in the right way, with some proposed changes to regulation around inspection. And with that, I'll turn it over to questions.
Great, thanks very much, Tyson. So we have one more panelist. We have Christopher Parks from the Public Advocate's Office. And Chris, I believe you were sharing a presentation.
Yes, I would like to. May I share some slides?
Yeah, feel free.
I guess I need for this slide to go down. Okay, thank you. Just a moment here. Thank you. Hang on just a moment. So I am Chris Parks. I am a supervisor in the safety branch of the Public Advocate's Office. Are you able to see these slides okay? Okay, great. Thank you for this opportunity to discuss Green Grid recommendations for additional safety considerations. Yes, we need the electron worthiness system proposed by Green Grid. Yes, we need to replicate the proven FAA airworthiness process and the CAS system and tailor it for energy safety in California. I have some slides to bring forward some information that I believe is useful when developing a path for carrying out this Green Grid recommendation and to supplement it. Quick overview. First, I'll do a quick recap on background and objective. Then I'll discuss two specific recommendations. Recommendation bullet 3 provides some context and analogy for how the CPUC's General Order 167 is a reference for how to implement electron worthiness for the electrical energy sector. GO 167 is the Commission's general order for safety, maintenance, and operation standards for power plants. General Order 167 has many attributes similar to the electron worthiness recommendation and becomes an example for how to implement and oversee, which is important, electron worthiness for the electric system. Recommendation bullet 4 here highlights another complementary FAA safety system, the FAA's Aviation Safety Reporting System, sometimes called ASRS. We recommend that a safety reporting system should be adopted to complement the recommended electron worthiness system. One important element of the electron worthiness recommendation is that of surveillance and audits. We recommend that the regulator needs to be integral to that, conducting audits and oversights, as you'll see in our example of GO 167. So first, here's some background and context on the issues covered by PUC Code 326, which the electron worthiness recommendation addresses. Here are some graphics to provide a high-level context for power line wildfire risk. These graphics should be consistent with what CAL FIRE shared yesterday. Electric power causes approximately 10% of wildfires. This slide shows power line caused fires are among the most destructive. I'll just note here, this slide highlights all the fires designated as power line caused. I want to note that the destructive Woolsey and Tubbs fire, while not labeled power line by CAL FIRE, are labeled electrical and on this most destructive list. This graphic here is another way of understanding how power line caused fires are among the most destructive. And power line caused fires have resulted in numerous tragedies since 2017 in California. Power line caused fires are costly. I'll note that Green Grid touched upon issues obtaining insurance in California. This slide is actually from the insurance industry, talking about insured losses over several years from wildfires. Now to the objective. The objective of this workshop is to develop safety requirements for electrical infrastructure to address risks from climate change and wildfire risk. This has been directed by PUC Code 326. Just to highlight that the objective looks at additional safety requirements in response to requirements for transmission and distribution to address climate change and wildfire risk. A quick couple of graphics to put this in context of climate change and wildfire risk as required by PUC Code 326. Recent events have highlighted the exponential growth in wildfires, most recently experienced in this year and this month, just north of us in California. This really shows a dramatic escalation of area burned in Canada. And here's another graphic. This is also from the last source, which is PBS NewsHour, which provides a compelling graphic showing the exponential rise this year in out of control wildfires across the nation of Canada. Now, on to Green Grid recommends that leveraging a proven FAA system and applying this to California's electric system. In other words, they're recasting FAA's system called airworthiness to become what they've called electron worthiness. Yes, we need that. And the Commission's implementation of GO 167, which we already have, provides a path for how to do that, as GO 167 already shares some of the elements that you might find in an electron worthiness system. GO 167 shares many of the same attributes found in the airworthiness and the CAS system that Green Grid described. And GO 167 shares many of the attributes found in safety management system standards. So just to give some more insight into GO 167 safety management standards and being proactive. We should be proactive and less reactive. A common theme in our current regulatory structure is that an incident occurs, the Commission investigates the incident, deficiencies are uncovered, corrective actions are implemented. Problems with that approach are deficiencies are not identified until after the incident, and follow-up is transitory and it's related to that specific incident, that specific operator. So what we're recommending is to move forward with a proactive safety regulation by developing auditing safety management system standards patterned after the CPUC's GO 167 maintenance and operation standards that's currently used for power plants. Just to give you a little background on GO 167, the history of that was it was adopted in response to legislation after the 2000-2001 electrical energy crisis. Those standards are broad, operation and maintenance standards required by the legislature for power plants. The maintenance standards are actually relatively short, and the Commission developed guidelines to support them. And in a sense, those guidelines serve as best practices because they identify what the industry can do to implement those maintenance and operation requirements. The Commission then conducts recurring audits against those standards and power plants implement corrective actions. So just to highlight a couple of the core elements of GO 167, it has a lot of common elements with the safety management systems. It addresses issues that are often core to incidents. A lot of times an investigation may find an issue with how something was carried out. And if we adopt new risk management standards that don't address those core issues, those safety management systems that utilities already manage, then we will still be subject to those kind of incidents. It is necessary that the regulator audit the operator to those standards. And then it is necessary for an officer of the company to certify compliance with the standards on a recurring basis. This is a built-in infrastructure for handling safety management. It's less reactive and more proactive and can endure for the future for the folks who are handling this in the future. Now on to the last recommendation, which is the safety reporting system. I'll touch upon it briefly. Safety reporting systems have been used upon by regulators and adopted by regulators in other high-risk industries. They have some common themes. They're another FAA system that has been adopted to enhance safety. They are voluntary, they are confidential, they're non-punitive, and they're independent, and they help identify safety issues before they become an incident. So California energy industry needs this kind of a safety reporting system, and we believe it should be adopted as part of the safety improvements as part of this PUC code requirement. So that's it for me. Thank you.
Thanks very much, Chris. Right, that is the end of our last panel discussion. So I would now like to open it up for questions. I know it's Friday afternoon.
We have a question from Wendy Al-Muqdad.
Oh, brilliant. Hello, Wendy. Please go ahead.
Hello, can you hear me?
Yes, we can.
Okay, I'm Wendy with the CPUC Safety Policy Division. I have a question for both Chris Parks and for Green Grid. And I'm curious, the GO 167, I have to admit, I'm not super familiar with it. Is it similar to integrity management program that PHMSA requires? And I just wondered if there's any overlap there.
So I'll jump in on that. Yes, I would say that there are some similarities. PHMSA, or the Pipeline Hazardous Materials Hazardous Safety Materials Administration, has adopted some safety management system requirements. I'm not an expert on where they are identical or similar, but I think that yes, I think they include similar attributes. And I don't believe we have anything on the electric side, unfortunately.
So perhaps in addition, I don't know if you can still hear me, but I'm just wondering if in addition to looking at GO 167 and looking at the PHMSA Integrity Management Program could be, since that's implemented by GO 112, that could also be something to look at, Chris?
I would say definitely. I think there's a number of safety management system standards that are out there. PHMSA could be one. One thing I'll highlight about the GO 167 standards is that they are heavily based on maintenance and operations. And there's a number of core elements that I think are very important to implement, such as they will get into root cause analysis, they will get into leadership, they will get into uncovering corrective actions and how effective they are. At some point, we might want to pull up what's actually in the standards and in the guidelines, but they are very comprehensive. And at the same time, they are very flexible, I would say. So in that sense, I'm saying flexible in terms of being able to adapt to an evolving risk structure. But I think that that there are some core elements that are in GO 167 that I believe should be minimum things that should be in such a standard.
Thank you.
Thanks very much for your question, Wendy. Opening it up for further comment. Rain, can you see any hands raised?
There are no other hands raised at this time.
Okay. All right then. So the next item on the agenda is open discussion panel, and then we move on to the survey. So not quite time for the survey yet. So it's a Q&A that can be on any topic, and we sort of outlined 10 minutes for that. So I'd welcome any further questions on any of the matters we've talked about over the last 2 days. Andy, you've got your hand up.
Yeah, one thing I think we touched on a little bit sometime on the first day, and I think Green Grid brought it up again in the grid in the section around inspections and repairs. But that regards to the regulatory requirements around ignition, specifically the ignition reporting requirement, right? I think they didn't bring that up specifically, but I think as we heard in the first part of yesterday was that catastrophic fires happen on high risk time periods. Dr. Mitchell mentioned that specifically and quoted numbers on that specifically, and all of the numbers when you look at catastrophic fires, they occur in very concentrated periods when the risk is high. The reporting that currently happens is all CPUC reportable ignitions that happen in high fire threat districts. In fact, all CPUC reportable ignitions meeting the threshold of greater than 1 meter originating from utility assets. And I would offer that maybe we should ask for that reporting to be nuanced a bit more as to what are the ignitions that have occurred when the risk conditions are a red flag warning day, or the risk conditions are however each utility defines that fire potential index. I know PG&E has a 1 to 5 scale, but anything above a scale of 3 is something we say, hey, the risk is elevated. And because those will actually provide us a lot more nuance and remove ignitions that may have happened during a storm event where it's also wet outside and you get a small ignition. So just offering that up for consideration specifically.
Thanks very much, Andy. Any further comments, feedback, questions, discussion points?
Yes, we do have another question from Wendy Almukdud.
Go for it, Wendy.
Thank you. Yeah, I have a question for the 3 utilities, because it was mentioned quite a few times, especially I think by PG&E, the early fault detection, the RF sensors being utilized, to monitor, to detect incipient faults. I wonder, can you all tell us how many miles are currently being monitored by this early fault detection technology for each IOU?
Wendy, I'll speak for PG&E. I can't give you the exact number top of my head right now. We have been running a pilot for a while and slowly deploying out early fault detection. There's 2 types. There's early fault detection, and there's what we called, I think it's distribution fault analysis. We put them together, EFD and DFA, those 2 technologies, and they have appeared in our wildfire mitigation plans. We're still in the pilot stage of those, though we do have some deployed, and we can get you the exact number in terms of miles and with circuits specifically, as well as kind of what we found, if that's of interest to the CPUC and the SED.
Yeah, that would be nice. Can we hear from Edison and SDG&E?
I can speak up for SDG&E. Again, I just pinged the team to see how many miles. I don't work in that group in terms of where they've deployed the sensors. We actually have the sensors on both underground and overhead, and we actually started the program on our underground system. But I will just kind of mention some of the pros and cons. I think in terms of the early fault detection, what I've seen is that while it does give basically a indication that there's something happening, a difference in previous measurements, it doesn't exactly tell you where on the line or what the issue is. And so from a continuous monitoring perspective, it gives us this indication, but then there is a need for us to go out and actually patrol, use other technologies such as infrared or just binoculars, drones, to see if we can figure out what the sensor is telling us is different. And so there is still a lot of resource impact that happens when we get these indications. And I believe the software and the analytics is still learning in that space to make sure that the continuous monitoring actually gives us better data and helps us identify what it is we should be looking for, what type of equipment, and we're seeing more investment, I guess, by a lot of the vendors that are creating this to get more refinement, but it's not quite there yet. And that's why there's a lot of pilots that you hear from, it sounds like PG&E and as well as SDG&E, but we're definitely investing in that technology and making sure that we know when it's ready to deploy at scale. Right now, we still really need to learn. Otherwise, we're just getting these indications and we're not able to really hone in our resources on where to look and what to look for.
Great, thank you. And I think in terms of Edison, Carl put in the chat that there aren't any Edison subject matter experts on at this time, but he's going to take an action away to follow up and get back to you on that, Wendy.
Okay, thank you.
I'd like to ask for any further questions or discussion points before we move on to the end of workshop survey. Rain, are there any hands up? No, nothing extra. Okay.
No, sorry, we don't have any hands up, but we do have a question in the Q&A.
Oh yeah, I think I just read that out, so we're good there. Thanks for flagging that. Okay, well, we'll move on to the end of workshop survey now. So that's the same as the survey yesterday. Fred, would you be able to put the link in the chat? So you can either use this QR code or you can click on the link that hopefully Fred's going to put in the chat and click on that. And it's to take your feedback, to understand what you thought of the workshop, to glean any further thoughts or comments or feedback from you, and also possible areas for improvement. So I'll just give you a minute to complete that. And then we'll just finish up. I just have one more slide left. I just wanted to go through some next steps before we finish. So I'll just give you a minute to fill out the survey. Thanks, Fred, for putting that in the chat. Okay, so I think we can probably move on to close out next steps. So I wanted to provide an overview of what's going to happen next on this project. So I think you should all be aware, in the public workshop notice, we're accepting these verbal comments at the 2-day public workshop, but we're also accepting written comments until July 28. So we said that these must be no longer than 25 pages and they should be filed to the Energy Safety e-filing system. So to the docket, the Wildfire Safety Requirements Recommendations docket, which is hash 2023-WSRR. I've just put it on the slide so that you can refer back to it. So public input will be considered by both Green Grid and Energy Safety in the development of recommendations for safety requirements to address the increased risk from climate change and aging infrastructure. So Energy Safety will be developing some recommendations to provide the CPUC in around the fall of this year. So these recommendations will be feeding into the formal CPUC proceeding, the climate change adaptation proceeding, which will be exploring changes to the existing safety requirements starting in the second half of 2023. So our recommendations will be feeding into that. And our recommendations will be public. We haven't bottomed out yet exactly the finer details of the public process around our recommendations, but we do know that they will be public. We may be seeking comments on them before they go to the CPUC, or we may go through the public process once we've issued them to the CPUC through the climate change adaptation proceeding. And so that's those are our next steps. If anyone has any questions, I'll try my best to answer them. Opening it up for any final questions. Chris from Cal Advocates.
Thank you. I just had a question. It mentions here these will feed into the formal CPUC proceeding, the climate change adaptation proceeding. So I'm just curious, for example, like the topics that we discussed at the last part here. I'm just curious, will they be, I'm just wondering how they will fit into the scoping of existing proceedings, or could they be implemented in, say, another proceeding that the Energy Safety may want to initiate or something?
So we'll be taking everything that we discussed today, including your comments, Chris, on the safety management system, and looking at your specific recommendations in terms of taking from other safety management systems that have already been implemented. And we'll be developing a set of recommendations for the CPUC, and they will feed into their proceeding. The climate change adaptation proceeding has got a track, I think it's a track A and a track B, or track 1 and a track 2, I don't know which one. Anyway, the safety recommendations and exploring new recommendations for safety requirements is going to be considered in the track 2 of the climate change adaptation proceeding. That hasn't been scoped out yet. That's going to be kicking off at some point in the second half of this year, but right now there hasn't been any movement on it. And that's why we're doing our work now, so that we can influence the proceeding as it moves forward.
Thank you for explaining that.
No problem. Okay, so it looks like we're able to finish about 20 minutes early. So I just wanted to take a moment to thank all of our panelists, and especially Green Grid, for all of their hard work on the presentation. A lot of effort has gone into this, and I really do appreciate everyone playing their part to make this workshop a success. So thank you very much. And I'd also like to say, have a great weekend, everyone.
Thank you.
Thank you. Thank you, everybody, for your
Thank
participation.
you.
Bye now.
Lucy.